Hi everyone, so we have brought a new series on our channel, that is F5Q series. So don't skip this part, first understand about this series, then you can start solving the problems. So in this series we are going to bring 50 amazing questions. Those will not be PYQs, they will be some good questions, and the level will be pretty good. Also those like we are going to bring all the subjects, so 50 amazing questions we are going to bring, and all the patterns will be covered. Like if there are 10 chapters, then questions from every single chapter, from every single topic we will be covering, right? And we will be giving multiple approaches as well. Now how you should utilize this video. So just as the video will start, there would be question and I will immediately start solving it. There would be very rare chance that I will be reading the problem. I will directly start solving it. So just you need to go to the question and pause the video there. Pause the video, solve it on your own, give your time, and then watch the solution. Okay, so in that manner you need to proceed, because I will not give any time. Just as the video starts, I will start solving the problem. So there I am not wasting any time. In the whole video I will be solving the problems only. So you just need to pause the video there and then you need to solve and then proceed. Pause, solve, proceed. In that manner you need to do. Okay, usually teachers give the time to solve the problem, but this thing will not happen here. So that's how you need to utilize. And secondly, even if you are not able to solve the problems, then no need to worry, because the level of the questions are pretty good. Certainly you are going to learn a lot of new things. It might happen that in 50 questions you learn 50 new things. That can also happen. So don't be demotivated. The only meaning here is that don't be demotivated if you are not able to solve the problem. Try learning from here. Okay, try learning new things, because the questions level of the problem will be pretty good, and certainly you are going to learn a lot of new things. So we have thought of this initiative. Certainly we are going to bring more subject, but it all depends on your response. So we are expecting a very good response from your side, and what we expect, only my target is the comments. Watch the video, see the content, and then let me know how did you find the content. Okay, how did you find the level of questions? Have you seen these kind of problems anywhere? Have you seen these kind of approaches anywhere? So that comment I am expecting from your side. Okay, and certainly if I get enough comments, if I get enough motivation, then certainly we will bring more subjects as well. So it all depends on your response. I am not asking for likes or anything. I just want your comments. I just want your reviews. Okay, and those who are preparing for GATE 126, for them these are the courses we are having, and this is for GATE 125 students. So if you are someone who is lagging behind in some particular subject, then you can purchase this course. It is just available in 299 rupees. You just need to go and apply the code Fusion. So let's just say I'm lagging behind in digital electronics, or I'm lagging behind in analog electronics. So all those courses are available here. If you are lagging behind in a particular topic, you can go and watch that topic and prepare for your examination. The validity of this course is till 1st of Jan. Sorry, not 1st of Jan. Sorry. 15th of Jan. The validity will be till 15th of Jan. So you can go and purchase the course. You can go and purchase this course and strengthen your weak topics. And those who are preparing for 2026 examination, they can go and apply the code Titans 40, Titans 40, TITANS 40, Titans 40. They can apply this code and they can avail these courses as per their branches, EC or electrical. Also, we have subject-wise courses as well, combo courses as well. Along with that, we are having placement courses as well. So for GATE 126 courses, we have the promo code Titans 40. So it will work on all the GATE 2026 courses, whether it is combo course, whether it is a subject-wise course, it could be any course. So in all the GATE courses, this code will work, Titans 40, and this is for GATE 2026 aspirants, right? And test series is also there, so you can go and make your purchase as per your convenience. Okay, then thank you very much. Now we will start the video, and in the video we will talk about the questions. So now the first question will come. You need to pause the video and start solving it and then proceed in the video. So first we will see the basics, then we will see the network theorems, then we will see the transient. After that, other things will come. Okay, yeah, thank you. Yeah, and one more small thing. This is the part 1 of network analysis. Here we are not covering the AC part. Here we are only covering the DC part. So once we are done with the DC part, after that we can bring 20 more questions on AC part as well. So AC part and 2 port, both are missing here. AC part plus 2 port, both are not there. Only DC part. Which part has been covered here? Here basics has been covered, network theorems has been covered, and transient has been covered. So in all these 3 topics we are covering 50 questions. So the part 2 will also come for network analysis. Part 2 will also come. This is part 1 only. Okay, yeah. So now we will start solving the problems. Thank you. Let's see the solution of this one. This was a very good question. So a cylindrical wire is wrapped around to form a circle, as shown. The equivalent resistance between X and Y is R. The equivalent resistance between X and Y is currently R. It is R. And then what they are asking, what would be the equivalent if A and B value are double, then what will be the equivalent resistance? So let's just see what kind of resistance this particular structure will provide me. This particular structure, what is this? This is a simple wire. This is a simple wire only, right? What is the radius of this wire? Can you tell me? B minus A by 2. Say yes or no. B minus A by 2. Agreed? And what will be the length? 2 pi b. This length will be 2 pi b and this radius will be b minus a by 2. Do you agree to my point? So what is the resistance it will provide? Resistance is proportional to, resistance is equals to rho L by A. That means this resistance will be proportional to the length. Length is proportional to b divided by A. What is A? B minus A by 2 whole square. This is the cross section area. Actually it will be, cross section area will be pi A square, pi R square. So that would be pi into b minus a square, b minus a by 2 whole square. But this is proportional to this value. The resistance R is proportional to this value. Now what is happening? You are doubling A and B value. So what will be your new resistance? You are doubling A and B value. Basically this R resistance which I am showing, this R resistance which I am showing, and this R resistance which I am showing. This was the R. So both are connected in parallel only. So effectively they are providing you R by 2. So your R by 2 is proportional to this one. So basically your R is proportional. Equivalent resistance is proportional to this value. You just need to find this value. So now what new thing is happening? The values are doubled now. A and B values are doubled. So what this will be? This will be B minus A. Say yes or no. A and B values are doubled. So the 2b minus 2a by 2. So this will be b minus a. And what this will be? 4 pi b. Right? This will be 4 pi b. Now values are doubled. Basically here what will be your R new now? R new. So instead of b you will write 2b here. Divided by, instead of b you will write 2b and instead of a you will write 2a. So a 2 you can take common and square is there, so it will be 4. So b minus a by 2. Basically it was doubled, so square will be 4 and this is getting cancelled. So R new is proportional to R by 2, R old by 2. Right? It is becoming half. New one is becoming half. So answer is R by 2. Option B. Are you getting this point? Look, first it was R, so R is actually R by 2. I should call this one as R double dash. If I call this as R double dash, then your R was R double dash by 2. And here I am showing this was your R double dash. This was your R double dash. So R is proportional to R double dash only. So I need to check R double dash. So it was B upon B minus A by 2 whole square. If B is doubled, that means this is doubled, this is 4 times. So R is becoming R by 2 now. Okay, so this was a very good question. Okay, let's see the solution of this one. This is very conceptual question. So here 3 ampere current is coming. From upward, how much current will come? This is open circuit path. From upward there will be 0 ampere current coming, right? So this is 3 ampere, then what this current will be? This current will also be 3 ampere because this is 3 ampere, from upward there is 3 ampere current coming. So this current is 3 ampere, right? This current is 3 ampere, this current is 3 ampere. That means this current is 3 ampere, so this current is completely flowing in the loop. So from upper side there is no current coming. So certainly this current will be 0 ampere only, right? So yes or no? You can apply KCL at this node. At this node, you can apply KCL at this node, at node X. So from node X, what is the outgoing current? 3 ampere. What is the incoming current here? 3 ampere. And what is the other incoming current? I. So what you can do? Outgoing current is 3 ampere. Incoming current is 3 ampere. Another incoming current is I is equals to 0. So what is the I value you are getting? 0 ampere. You can apply KCL or you can see conceptually only that this complete 3 ampere current is flowing in the loop. So no current is going downward. So these kind of circuits we will be using in analog circuits. Okay. In analog circuits, this kind of circuit will come in front of you. So you should be aware that if a current is flowing in the loop, it will not go downward. Okay. Thank you. So let's check out this question. This was in our class notes only. So this is bulb P1, P2 and P3. All are rated at V voltage. For operation specific mains voltage are connected shown below. Each bulb is rated at V voltage. So what do you mean by that? What will be the resistance? Voltage rating divided by P. V square by P. V square by P1. This resistance would be V square by P2 Because resistance does not change. First thing, when you are solving a bulb problem, what you will do? You will find the resistance, rated voltage upon the power, V square by P3. Voltage rated upon power, voltage rated square upon power, and the supply is also V. What do you need to find? The total power supplied by the means. So basically you need to find the current here now. If you find the current, that would be it. What is my target? My target will be to find the current. What will be my power? V into I. So my target is to find the current. Okay, so what will be my current? My current will be, I will be equals to V upon V square by P1 plus V square by P2 plus V upon V square by P3. Basically this voltage V is going here. So this current I am writing and this current I am writing, that is equals to I. V square by P1 plus V square by P2. These two resistance in series plus this V voltage is going here, V upon this resistance. That's it. So what will be my power? Power will be V into this current. So what that would be? So V into this current would make me V square here, V square by P1 plus V square by P2 plus V square upon V square by P3, right? So what you will get, V square is getting cancelled. So P1 P2 upon P1 plus P2 plus P3. P1 P2 upon P1 plus P2 plus P3. So slowly if you solve these kind of problems, it will be solved, no issue. Okay, let's see the solution of this one. This was also a very good problem. So this 1 ampere current is flowing in this manner. This 1 ampere current does not have any other path, so it has to flow like this only. Do you agree to my point? This is the 1 ampere current. Are you getting this point? This 1 ampere current will keep on flowing, and this will be the 1 ampere current, right? Agreed? Totally agreed? Okay. Now this is 0, this is 1 volt. So this node is 1 volt, so this node will also be 1 volt. Now 1 volt by 1 ohm, this will be 1 ampere current. This is 1 ampere current, right? What will be this current? Can you tell me? You need to find this current I. What will be this current? If this is 1 ampere and 1 ampere is going down here, what do you understand by that? What this current will be? 0 ampere only, right? You can apply the nodal here, you can apply the nodal here. 1 ampere current coming inward, X current coming inward, 1 ampere current going outward. So X is 0 ampere. So this current is 0 ampere. So this X current is 0 ampere. Now what about this current? This current is I. So if this current is I and this current is 0 ampere, so I will be simply equals to 1 ampere. Are you getting this? Are you getting my point? This current is 0 ampere. Current going ahead. This is 0 ampere and this current is I. So I will be simply 1 ampere. Answer is 1 ampere. That's it. So this was a very good question. 1 ampere current is flowing here. This was the 1 volt. 1 ampere current is going down. That means this 1 ampere current is flowing in this loop and this 1 ampere current is flowing here. That's it. So basically what is the path of the current? 1 ampere current is flowing from the battery and the path of the current is this. I will show it with the dotted line. The path of the current is this. This is the path of the current. This is the 1 ampere current which is flowing in this path. It is not going here. That's it. Okay, well and good. So let's see the solution of this one. Here you need to find the resistance between 1, 2 and 1, 3. So first let's find the resistance between 1, 2 and 1, 3. So let's talk about point 4 and 3. So 4 and 3 are equipotential with respect to 1, 2. How they are equipotential? If you go from 4 to 1 or if you go from 3 to 1, there is equal path, right? That is R. If you go from 4 to 2 and if you go from 3 to 2, there is equal path, that is R, right? From 4 to 1, if you have looked for from 4 to 1, you have to see 3 to 1, okay, equal path. From 4 to 2, same path. From 3 to 2, same path. That means they are equipotential, right? And if they are equipotential, what does that mean? This resistance will go. Basically, this is your 1. Between 1 and 2, there is resistance R. And 3 and 4 are becoming same. 3 and 4 are becoming same. So between 1 and 4, there was R. Between 1 and 3, there was R. 1 and 4, there was R. 1 and 3, there was R. So this would be R by 2. Between 2 and 3, there was R. Between 2 and 4, there was R. This was 2. This was 2. Between 2 and 3 R, 2 and 4 R. So this will be R by 2. So between 1 and 3 you need to find. So what this will be? Both will come in series. This will be R by 2 plus R by 2 R. And R parallel R, R by 2. So between 1 and 2 it will be R by 2. Let's check for 1 and 3. 1 and 3. So for 1 and 3 we are checking. Now for 1 and 3. So what about point 4 and 2? Point 4 and 2 will also become equipotential because 4 to 1, 2 to 1, same path. 4 to 3, 2 to 3, same path. That means 4 and 2 are also becoming equipotential. So this is your 4, 2 and this is your 3. So between 1 and 4 there was R, 1 and 2 there was R. So this will be R by 2. And between 4 to 3 there was R, and between 2 and 3 there was R. So R by 2. 4 to 3, 2 to 3. Between 1 and 3 there is R. Between 1 and 3 there is R. So R parallel with R is R by 2. So R by 2, R by 2. This is the answer. Some people would have missed this R, right? In this particular scene, they would have missed this R and they would have taken on this. But that is wrong. Okay, this is wrong, this is correct. 1 and 3 there is also one resistance, okay? Because the resistance of each edge is R. So this is also edge. Okay. So answer is R by 2, R by 2, this option. So let's see the solution of this one. So this is the best question of this complete test series, okay? And I can say 0% guys would be able to solve it. Not even 0.1%. 0% I am saying. Even if I had been the aspirant, I would not be able to solve it. Okay. So yeah. So this is a uniform wire and represents a regular 5-pointed star. Regular 5-pointed star. So in a regular 5-pointed star, what is the scene? These side, this side, this side, this side, all are equal. What is your resistance? Resistance is proportional to length by A. Wire is the same, so A is the same only. Now all will depend on length. Everything comes down to length. Everything comes down to length now. Okay. So all these are equal. That means KD, DK, KD, DL, all these are equal. So I am not going to write all the lines, but you can see KD, DL, LE, FE, all these are equal. And so on, it will keep on going, CH and CK. But what about these length? KL. What will be the length of KL? Because you know the resistance of EL. EL is 2 ohm. So all these resistance you also know, right? If you know the resistance of EL, that means this will be 2 ohm, this will be 2 ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm. All these are 2 ohm. But what about these resistance? What about these resistance? What about these resistance? What will be the resistance of these 5? KL, HK, KL, HK, LF, GF and HG. What about the resistance of these? So here the concept of geometry will be used. Your good amount of geometry will be used. So let me take a triangle here. Okay. This is your E, this is your F, and this is your L. EFL. This angle is 36 degree. You can derive it from geometry. This angle is 36 degree. This angle is generally 36 degree. Okay. 36, not 30. This angle is generally 36 degree. So let's make it on the next page again. So this angle is 30 degree, 36 degree, 36 degree, FLE, EFL. And this is one of the favorite question of gate aptitude. They many times ask this angle. This is 36 degree. Okay. People usually remember for a regular star, this angle is 36 degree. And in gate also it has been asked 2 to 3 times. In aptitude, not in certainly electronics, but in aptitude it has been asked. Now, and if I draw a perpendicular here, this will bisect. This will be 18 degree. This length I know. This length is L. EF length. EF length is L. This length I know. I need to find this length. I need to find FL. If I can find FL, this will be a regular pentagon. So FL all are equal. HK, KL, FL, GH, HG all are equal. This will be a regular pentagon. Okay, this is from the geometry. This complete structure is regular. Equal, equal. These are isoscalar triangle. Isoscalar. Okay. And angles are, this is 36 degree, rest you can find, right? And this will be a regular pentagon. These will be 108 degree angle. So from there you can derive it as well. If this is 108, this angle you can derive. What that would be? 72. 72 plus 72, 144. This angle will be 36 degree. So with this derivation you can do. One thing you just need to know, all will be regular. So HA is equals to KL is equals to FL is equals to GH is equals to GF. Right? So this angle will be 80 degree. This will be bisecting. This will be bisecting this. Okay. So what will be my FL? FL will be 2 times of FO. My target is to find FO. How I can find FO? FO will be what? I need to find FO. So how do I find FO? Sine 18 degree is equals to FO by L. Say yes or no. So FO will be equals to L into sine 18. So if you find sine 18, what you will get? Let's check that. So it is roughly 1 by 3. Sine 18 is roughly 1 by 3. So it will be L by 3. So what will be your FL? FL is 2FO. FL is 2FO. FL is 2FO. That means it will be 2L by 3. Then if the resistance for EF, if the resistance was R, then for this one what will be the resistance? 2R by 3. Say yes or no. For EF the resistance was R, then for this the resistance is 2R by 3. So for these, what did we get to know? For these the resistance is 2R by 3. For these the resistance was R, for these resistance was 2R by 3. So KL 2R by 3. This also 2R by 3. So these are 2R by 3. Now what you need to find? You need to find the resistance between F and C. F and C. So let's check that out. F and C. This is your C and this is your F. So between C and H there is R. Right? Between C and H there is R. Between H and G, how much resistance is there? Between H and G. So let's check H and G. H and G. So H and G. H and G there is 2R by 3. Right? This is 2R by 3. And in parallel to these two will come in series. BH and BG will come in series. What that would be? R and R 2R. This is your H. This is your G. 2R by 3 parallel with 2R. 2R into 2R by 3 upon 8R by 3. So what that would be? R by 2. Okay. So 2R parallel with 2R by 3 would be R by 2. So this would be R by 2. So this resistance would be R by 2. Same goes for this one as well. This resistance will also be R by 2. Now what about K? So between C and K there is R resistance. Between K and L there is R by 2. And here also it is. Between F and L there will be R by 2. And between H and K, there is what? There is resistance 2R by 3. What do you need to find? You need to find the resistance between C and F. C and F. What about this resistance 2R by 3? This is Weisstone bridge. Look here. 2R and 2R in coming series. R. This is Weisstone bridge. This will be nullified. Right? This will be open circuited. This is of no use. Weisstone bridge is there. This is of no use. Then between C and F. Between C and F, what do you see? R parallel R, R by 2. Then this is R by 2, this is R by 2. In series it will become R only. R parallel R, R by 2. So between C and F, what do you get? Between C and F you are getting R. So answer will be 2 ohm. That's it. So the motive behind this problem was just to tell you the thing that whenever like any kind of question can come in front of you in the examination, but you need to make sure that if they have given the resistance of a particular length, then you need to check the length as well. Okay, don't blindly say that like most of the people would have solved it in this manner that all will be of resistance R. But no, only EL was mentioned, EL was 2 ohm. This is 2 ohm, this will be equal to 2 ohm, but this will be different. This will be 2R by 3. So that was the main motive behind taking this question, that you should take care of the length as well. They can somewhere in some question, or let's just say in 2026 or 2027 or 2025, they can ask you the problem where they may ask you the question on geometry as well. So here the geometry was used. You had to find 2L by 3. So this was the concept. Okay, so this was a very good question. So in this one you need to find the value of Ix, right? So you need to find the value of Ix. So what we can do, we can find this current, right? because this current plus this current plus this current will be equals to Ix. So what this current will be? Now electrons are flowing in this direction, that means current would be flowing in this direction. No? If electrons are flowing in this direction, that means current would be flowing in the opposite direction. And what will be the current? Current I, there will be a negative sign because that will be opposite direction current. Current I will be Ne by T. So this was the most important point, people would have forgot here, the negative sign. If electrons are flowing in this direction, current in opposite direction. That is Q by T, and Q is equals to Ne, because charge is always quantized. So Q is equals to Ne. So how many electrons are there? 100 billion. That means 100 billion means 10 to the power 9. What is the charge on electron? 1.6 into 10 to the power minus 19 divided by time t, that is flowing in 1 nanosecond, that means 10 to the power minus 9. So what do you get here? 16 ampere, minus 16 ampere. So I is minus 16 ampere, that means if this is minus 16 ampere, so minus 16 plus 1, this would be minus 14. So answer will be minus 14 ampere. Okay. So Ix would have been minus 16 plus 2 plus 2 minus, sorry, plus 1 minus 14 ampere. 14 ampere. Well and good. So in this one, what you need to find? You need to find the value of I1. I1 at 3 millisecond. I1 at 3 millisecond. 3 millisecond. So this current will always be 10 milliampere. No one can change it. This current will always be 10 milliampere. Now this voltage is exposed here. This voltage is directly exposed here. So what will be the current through the capacitor? Current through the capacitor, ICT, or you can say IXT. That will be equals to C dVc by dt. C dVct by dt, right? Whatever the voltage is coming. And what voltage is coming? What is the value of C? That is 4 micro. And what voltage is coming? That is V1. dV1 by t. And at what point you need to find? You need to find at 3 millisecond. So Ix at 3 millisecond you need to find. So here I need to find at 3 millisecond. So what is the slope at 3 millisecond? What is the slope at 3 millisecond? The slope you can find at 3 millisecond, the slope is minus 1. You can check from here, right? 3 and here 3. The slope is minus 1. Slope is minus 1. Okay, you need to check the digit as you need to check the unit as well. So slope is dV by dt. So 3 by minus 3 by 3 minus 3 by 3 milli. That means slope is minus 1 kilo. Minus 1 kilo. That means minus 10 to the power 3. So 4 into 10 to the power minus 6 into 10 to the power minus 3. 10 to the power 3, sorry. 10 to the power 3. So this Ix would become minus 4 milliampere. So this current is minus 4 milliampere. That means 4 milliampere current is flowing upward. And if this is 2 Ix, that means this will be 8 Ix, 8 milliampere current flowing upward. 2 Ix is going down, Ix is negative, that means 8 milliampere current going upward. So this is your 3 milliampere. This is your 10 milliampere. Sorry, this is not 3 milliampere, this you need to find. Sorry. This is your 10 milliampere. This is your 4 milliampere. And this is your 8 milliampere. So 12 milliampere current is coming from here, 10 is going here. That means this current would be minus 2 milliampere. Basically 2 milliampere current would have been going here. 8 plus 4, 12. 10 is going here. 2 milliampere would have been going here. So this is minus 2 ampere. So answer is minus 2. That's it. Okay. This was a good question. So let's solve this one. Here you need to find the power delivered by the battery. That means you need to find the current here. Because if I know the current, V into I, that will be the power. So let's take this point. I will convert this into star network. Okay. From delta to star I will do here. This I am going to do. 1 by 3 it will come. So in the examination, how I would have been doing it, because in the examination the question will be on the screen, not on paper. So I will be drawing a battery like this, 1 volt. Then I would see the positive terminal is connected to 1 ohm. I am not going to do anything with that. Now this node is connected to another 1 by 3 ohm. This node is connected to 1 by 3 ohm. this is how I will be making the circuit in the examination by looking at the screen. 1 by 3 ohm, 1 by 3 ohm and 1 by 3 ohm, right? And now this is connected to 1 ohm in this manner. This is connected to 1 ohm in this manner, right? So this is how I will be doing in the examination. Now I will get to know that this 1 by 3 and 1 ohm are connected in series. 1 by 3 and 1 ohm are connected in series. So what this will be, 1 by 3 plus 1 ohm, that will be 4 by 3. That would be 4 by 3 ohm. And now this 1 and 1 by 3 again are connected in series. So this will also be 4 by 3 ohm. And this is 1 volt and 1 by 3 connected in series. 1 volt and 1 by 3 connected in series. And this node is common. This node is common to all. This is 1 by 3 ohm and this is 1 volt battery. So 4 by 3 and 4 by 3, what it will become? 2 by 3. 2 by 3 and 1 by 3, what that will become? 1. So 1 volt battery and 1 ohm resistance, right? Yeah, so what will be the power? Power will be 1 watt only because current will be 1 ampere. So power delivered by the battery. What they are asking, power delivered by the battery. That would be 1 into 1. That means 1 watt. This answer is given wrong here. This answer is wrong, which I will be modifying. So this answer will be 1 watt. Answer is 1 watt. Okay, well and good. So let's solve this problem. This is one of the finest problem. Also, this was there in our notes as well, right? In class notes as well, it was there as far as I remember. And this kind of question was asked in GATE 2022 examination. So almost similar question was asked. So how we will solve it? So this resistance R will be replaced by this battery, and then you need to find the current I. This is the question, right? What is V and I? What we need to find? And variable resistance is R is varied. Here I did not even write what I need to find. So you need to find the value of I. This you need to find. Okay. So you need to find the value of I. So how you will do it? So this much of block you can replace with VTH and RTH. Our area of region, interest area is this one, this much only. So here I will replace this VTH and RTH. VTH and RTH, or I can get short circuit current as well, or Norton current I should say. So anything I can get. So how will I do it? So what will be my VTH? What is VTH? VTH is actually open circuit voltage. VTH is what? Open circuit voltage. So whenever your output is open circuited, what is the voltage you are having at the output? This is what you mean by Thevenin voltage, right? So what is your Thevenin voltage here? 5 volt. What is your RTH? Can you find RTH here? Just I need your answer, yes or no. Can you find RTH here? No. You will say that, sir, the slope of this one will be your RTH. The slope of this one will be your RTH. Luckily, you will get the same answer, but that concept is wrong. Why that concept is wrong? Because what is RTH? RTH is the resistance looking from this node, but considering independent voltage source to be 0. Here, this characteristics is there without considering this one to be 0. Are you getting this point? This VI characteristic is coming without considering this to be 0. So this might be affecting VI. Say yes or no. So you cannot say that directly, sir, you calculate the slope, that will be my RTH. Nah. Are you getting this point? So we cannot find RTH from here. So we will try for I Norton now. So let's draw the waveform. This is the waveform. And this was the slope. 5 volt. And here it is 4 volt. And this is 1 milliampere. This is I and this is V. Right? So how will you write the slope first? First I can write the slope. So what will be my slope? Y2 minus Y1, 4 minus 5. I am writing the equation of this line. Basically, I need to write the equation of this line. 4 minus 5 divided by 1 milli minus 0. 4 minus 5 divided by 1 milli minus 0. So slope will be 1 kilo. Minus 1 kilo. Slope will be minus 1 kilo. Minus 1 kilo. It will be minus 1 kilo ohm only, but unit doesn't matter. What you need to find now? You need to find the relation y equals to mx plus c. So minus 1 kilo into x is I plus c. C is 5. Now what do you mean by ISC? What is your short circuit current? Your short circuit current is when your output is shorted. That means this voltage V is 0. If you need to find Norton current, you need to put this V equals to 0. Do you agree to my point? Short circuit current is when your voltage V is 0, at that time whatever the current you get. So I Norton into 1 kilo ohm will be equals to 5, because at I Norton, at I equals to I Norton, V will be equals to 0, right? So IN is 5 milliampere. IN you are getting is 5 milliampere. So what will be your RTH? V by I. Luckily that is 1 kilo ohm. That is coming out to be equal to the slope only. But here you need to take care of the things that this you cannot say that this is your RTH. You need to find the ISC. Then only you can get your RTH. So what will be your RTH? RTH will be IN into VTH. And IN direction also you need to take care. Here the direction was same. Let's just say this was my block. This was my linear network. So here this was the direction. So direction should be coming inward. So that is correct. If it was going outward, then that here I would have put a negative sign. So 5 milli into 5. That means 5 milli into 5. Wait a second. Sorry. sorry. RTH is VTH by IN. It's been very late at night, so I'm really sorry for this mistake. 5 by 5 milli, this would be 1 kilo ohm. So VTH and RTH you have, that is there. VTH and RTH are there. So your VTH is 5 volt and RTH is 1 kilo ohm. 5 volt, 1 kilo ohm. And here there is 1 kilo ohm and 3 volt. 3 volt is there and 1 kilo ohm is there and 1 kilo ohm is there. What you need to find? You need to find the current I. You need to find the current I. So what that current will be? 2 by 2, 1 milliampere. I will be 1 milliampere, right? So I will be 1 milliampere. Option 3 is correct. Very easy question. You just replace this with VTH and RTH, and then you go to know that RTH is not the slope. I found ISC, and from there ISC, or you can say I found I Norton current. From there I go to know the RTH. That's it. Okay. Let's see the solution of this problem. This is very good problem. Here you need to find the power delivered by the current source. So what will be our target? Our target will be to find this voltage, because power delivered. So I need to find this voltage. Okay, this is my target. So if I go by some analysis, let's see what will be this current. This current will be Vx. Do you agree to my point? Because across 1 ohm there is Vx voltage drop. So this current will be Vx. Now 1 volt plus Vx. 1 plus Vx is the voltage across this. Say yes or no. 1 plus Vx is the voltage across this. 1 plus Vx. That means what will be the current in this 1 ohm resistance? That will be 1 plus Vx only. Because 1 plus Vx by 1 will be 1 plus Vx. And here there is Vx current. Vx current here, 1 plus Vx current here and 1 plus Vx current here. That means how much current would be coming from here? 1 plus 3 Vx. Are you agreeing to my point? I am trying to find the value of Vx. This is my target. So I go to know that this is my Vx current. 1 plus Vx, this is my current, 1 plus Vx. Vx current is here, 1 plus Vx current is here, Vx current is there. That means this current would be 1 plus 3 Vx. Right? Agreeing to my point? Now if this current is 2 ampere, this current is 2 ampere. And this current also you know, this current also you know. So you can find the current here. Let's call this current as X. So what will be your X current? So at this node I can apply nodal. So X is the outward current plus 2 ampere is the outward current minus Vx is the inward current and 1 plus 3 Vx is the outward current is equals to 0. 4 branches are there, this current, this current, this current. Okay, fine. So X plus 3 is equals to plus 2 Vx is equals to 0. So X is equals to minus 2 Vx plus 3. Minus 2 Vx plus 3. That means in the upward direction, if this was your X, so in upward direction, what is the current flowing? That is 2 Vx plus 3. In upward direction, 2 Vx plus 3 current is flowing. Now I need to find the value of Vx. So what I can do? I can see one thing, that this voltage drop, I can apply nodal in this loop. I can apply nodal in this loop. and this will also come in action. So 2Vx here and 2 ampere current here. So you need to find the current in this one as well. This also is remaining. Let's find the current here. So let's call this current as Y. So Y plus, I am applying nodal at this node. So Y is inward. So let's write inward current only, and 2 ampere is also inward, and 2Vx plus 3 is the outward current. So this current would be 2Vx plus 1. So this this Y current would be 2Vx plus 1, right? Now I can apply nodal in this loop. Not nodal, sorry, I can apply KVL in this loop. So how I will apply the KVL? So I am moving in this direction, from plus to minus I am moving. So minus I am writing as plus only. So 2Vx by 3 plus 3, then plus 1 plus Vx plus 2Vx plus 1 is equals to 0. So 2, 3 and 5Vx is equals to 8 minus 8. So let's check if I have calculated it right. Yeah, so this is correct. Vx is equals to minus 8 by 5 volt. Vx is equals to minus 8 by 5 volt. Now what will be the voltage drop V? Voltage drop V will be 2Vx plus 3, right? So that would be minus 16 by 5 plus 3. That would be minus 1 by 5. So this will be minus 1 by 5 volt. So what will be the power delivered? Power delivered will be 2 into minus 1 by 5. That would be minus 0.4 volt. Minus 0.4 watt. This is actually wrong. Answer will be minus 0.4 watt. I will modify it. Okay. So let me check if there is an error. Power will be V into I. So 2Vx plus 3, 2Vx minus 16 by 5 plus 3 minus 1 by 5 into 2. Yeah, okay. I will modify it. So in this question you need to find the power dissipated. Find the order of the power dissipated. So what will be your power dissipated? Power dissipated will simply be I square into R, right? Current I is same. So power is proportional to the resistance R. That's it. Current I is same in all. So power will be proportional to the resistance R. Now someone will say that sir, power is V square by R. So power can be inversely proportional to 1 by R as well. There is no information about voltage. There is information about current, that all are having the same current. So power is proportional to R here. Well and good. So what is R here? R by 3. What is R here? 3R. What is R here? 2R parallel with R. That is equals to 2R by 3. And what is R here? R by 2 plus R by 2 plus R. R by 2 plus R. That is equals to 3R by 2. So this is 0.33. This is 3R. This is 0.66. And this is 1.5. So which one is the largest one? P2 is the largest one, then P3, then P4, and then P1. 2, 3, 4, 1. That's it. Very easy question. So let's solve this problem. A wire of resistance 0.1 ohm per centimeter is bent in a square of ABCD. Square of ABCD. What do I need to make? Square of ABCD. There you go. Square of ABCD of one side equals to 10 centimeter. One side equals to 10 centimeter. One side is equals to 10 centimeter, and resistance is 0.1 ohm per centimeter. That means for 10 centimeter, what will be the resistance? For 10 centimeter, the resistance will be 1 ohm. So 1 ohm here, 1 ohm here, all are 1 ohm. All are 1 ohm because length is 10 centimeter. Now a similar wire is connected between the corners B and D to form a diagonal BD. Okay. What will be the resistance of this diagonal? Can you tell me? This length will be root 2 times of this, right? Root 2 times of this. So resistance will be root 2 times as well. So this will be root 2 ohm. This is 10 centimeter. This is 10 centimeter. So what will be the length? 10 into root 2, and resistance is proportional to the length. So basically, it will be, resistance will be root 2 ohm. So this resistance will be root 2 ohm. Okay. Then what they are asking? Find the effective resistance of this combination between corner A and C. Between corner A and C. You need to find. So B and D are equipotential because from B to A and D to A, same path. B to F, B to C, and D to C, same path. So B and C are equipotential. So what will be the effective resistance? Effective resistance between A to C. 1 ohm parallel with 1 ohm, half. 1 ohm parallel with 1 ohm, half. This is of no use, right? So answer will be 1 ohm. Now what they are saying? If 2 volt battery is connected for of negligible resistance, then power dissipated. What will be the power dissipated? Power dissipated. So 2 volt battery is connected between A and C, and this is your resistance, which is 1. So what will be the power dissipated? V square by R, 4 watt. That's it. 1 ohm and 4 watt. Option B is correct. 1 ohm and 4 watt. Option B is correct. Well and good. So let's see this question. This is also a good question. So what you need to find? Potential difference across the terminal of a non-ideal battery. So this is how a non-ideal battery looks like. There is an internal resistance R, and this is a battery E. Battery E and R. This potential difference they are talking about. Okay. This potential difference they are talking about. And what they are saying? It is 0 when it is shorted. Yeah. When it is shorted, this will be 0. So first one is correct. Less than its EMF when current flows from negative terminal to positive terminal inside the battery. Negative to positive inside the battery. Negative to positive inside the battery. That means current is flowing like this. So if current is flowing like this, that means this will be the voltage drop. Let's just say this voltage drop is X. So what will be your V? V will be E minus X, right? V will be E minus X. That means this is less than its actual EMF, right? So this is also correct. Greater than 0 when no current flow, 0 when no current is drawn from the battery. If 0 current is drawn, that means what will be, this was the first, for the second case. What about this? If 0 current is drawn, then what will be V? V will be equals to E. So it is equals to EMF when no current is drawn from the battery. This is wrong. What about the last one? Greater than its EMF when current flows from positive to negative terminal. So if the current is flowing from positive to negative terminal, this was your option 3. If current is flowing from positive to negative terminal inside the battery, positive to negative inside the battery, that means it is flowing here in this manner. So what will be your V? V will be E plus X. So this V will be greater than its EMF when current flows from positive terminal to negative terminal. So this is also correct. So 1, 2, 4 are correct. Okay. Well and good. Let's see the solution of this one. This is also a very interesting problem, and here you will have to use your brain. So an EMF of battery E and internal resistance R is connected. EMF of battery E and internal resistance R is connected. E and R is connected across a resistance R. Across a resistance R. R can be adjusted to any value greater than or equals to 0. This would be from 0 to any value till infinity. Okay, greater than or equals to 0. Now what they are saying, a graph is plotted between between the current I passing through the resistance and potential drop V across it. So potential drop V and current I. So this characteristics V and I is this one. Okay, V and I is this one. Now you have to choose the correct alternative using this characteristics. Okay, which is the first one? The internal resistance of battery is 5 ohm. If you need to find the internal resistance of battery, then what you will do? You will put what you will do? You will want your voltage to be equals to 0. You would want this voltage to be 0, because if V is equals to 0, then I will be equals to E by R. So if V is equals to 0, if V is equals to 0, what is I? 2. So 2 is equals to E by R. So let's hold on to it, because we don't know the value of E, we don't know the value of R. We don't know the value of both. I need to find the value of R. So what I would do, I will try to put V equals to 0. If V is equals to 0, so I is equals to E by R. So I is equals to 2 ampere, 2 is equals to E by R. I don't know the value of E now. Okay. To find the value of E, what do we see here? If current I is 0, if current I is 0, if I is 0, at that time voltage V is 10 volt. When this current I can be 0? Tell me one thing. This is not variable, this is variable, right? And this will be some positive voltage only, right? And internal resistance of this one cannot be, internal resistance of battery cannot be negative, it will also be positive. So tell me one thing, when your current I can be 0? If current I is 0, that means your resistance is infinity. Say yes or no. So at this point, here your resistance is infinity. So if your resistance is infinity, that means the current I will be 0 and voltage drop will be equals to EMF only. So your EMF is 10 volt. So EMF of battery is 10 volt. Say yes or no. And if EMF is 10 volt, that means resistance is 5 ohm. Are you getting this point? Some people will have a doubt that, sir, if you are saying that current is 0, that means current flowing here is 0 ampere. So if current is 0 ampere, that means voltage drop will also be 0. So this characteristic is wrong. No, this characteristic is not wrong. This is saying that if your current is 0, your voltage is 10 volt. That means if current is 0, R is infinity, because R can vary from 0 to infinity. This doubt can happen that people will say 0 ampere current is flowing, so that will give voltage drop equals to 0. So here 0 and 0 should come. But now R is equals to infinity. At that time your current will be 0. So V is equals to 10 volt, that is equals to EMF. Because if current is 0, R will drop 0 voltage drop. So this V will be simply equals to EMF, and that will be 10 volt. And what will be your R now? 5 ohm. So 1 and 2 are correct. Maximum current that can be drawn from the battery is 2 ampere. Maximum current that can be drawn from the battery is 2 ampere. So what will be the current that can be drawn from the battery? What is the current that can be drawn from the battery? That current is E upon R plus R. So this value has to be minimum. This R is fixed. And if you want this to be maximum, so this has to be minimum. And what is the minimum value of R? 0. So E by R, E is 10 by 5, that is 2 ampere. That's it. So maximum current you can draw is 2 ampere. After that the graph cannot go like this. If it goes, it has to go like this only. But it will not go like this as well. Why it will not go? Why it will not go ahead? Because if it goes ahead, that means resistance will be negative. If current is negative, then certainly resistance will also be negative, and they are saying that the resistance is from 0 to infinity. So the graph will stop here. That's it. This is the graph. So it will not go ahead. So maximum current that can be taken is 2 ampere. This is also correct. Are you getting it? Why it is correct? Because you'd want this to be minimum. So this minimum is 0. So 10 by 5, 2 ampere you are getting. That's it. VI graph can never be a straight line with negative slope as shown in the figure. It can be a straight line. I just showed it. We just showed it. We just proved this question to be right. So it can be a straight line. Well and good. Okay. So coming to this problem, what you need to find V naught when VS2 is 6 volt. Okay. And this graph is given. So we don't know the value of VS1. So our target will be to find VS1 first. What is given? When VS2 is 0, V naught is 2 volt. When VS2 is 0, when VS2 is 0 volt, at that time V naught is 2 volt. So by using this thing, I can find the value of VS1. Say yes or no. Right? So this will be my VS1. This is my VS1. Then there is 3 ohm resistance. Then another 3 ohm. And here your VS2 is 0. VS2 is 0. So this will be simply grounded. This is 3 ohm. This is also 3 ohm. And your V naught is 1. Your V naught is 2 volt at that time. This is also 3 ohm. So from here you can get the value of VS1. What will be VS1? You can find the VS1 value. How will you find? This is 1.5. 3 and 3 parallel is 1.5. This is 1.5 ohm. So 1.5 divided by 4.5 into VS1 is equals to 2 volt. Right? Simple network analysis it is. So VS1 is 6 volt. So VS1 value you are getting 6 volt. Now what they are saying? When VS2 is 6 volt and VS1 is certainly 6 volt, you need to find the value of V naught. So VS1 is fixed, that is 6 volt. And now this is 3 ohm. This is also 3 ohm. This is also 3 ohm here. And this will be grounded. And VS2 is 6 volt. So you need to find the value of V naught. So this will be your V naught. So V naught you can find, you can apply any method. You can apply the nodal analysis, right? V naught minus 6 by 3 plus V naught minus 6 by 3 plus V naught by 3. So what you are getting? 3 V naught equals to 12. So V naught is equals to 4 volt. So 4 volt is the correct answer. Okay. So this was a good question. So let's see the solution of this one. This is a common data question. You need to find the value of I1 and also you need to find the value of I2 in the same circuit. So from 7, 1 ampere is going. And at this node, at this port BB dash, this is shorted and 3 ampere current is going. Now what do? I double this and I change the port 7 to 14, and then this I1 current I am asking. Can you determine the current I1? The same question was there in our class notes as well. You cannot determine the current I1. I told you one thing, that if your source and excitation are at same port, then you can determine at the same port only. That means if this was my circuit, let's just say this is the circuit A dash. Here I am saying that 7 volt will give me 1 ampere current. So in the next circuit as well, then only I can apply reciprocity theorem when I am determining this at the same port only. If my source and excitation are at the same port, that means I can determine the other parameters on the same port only. That means if I apply 14 here, then I can say that my current will be 2 ampere. If this is 7 will give me 1 ampere, then 14 will give me 2 ampere, but AA dash, but at AA dash, not at BB dash. Okay, you cannot change the port from AA dash to BB dash. But if source and excitation are at different point, let's just say at AA dash your source is there and excitation is there at 3 ampere. So now you can interchange. So 14, this will give you 6 ampere. From here to here, 7 will give you 3, then 14 will give you 6. But if you are collecting at the same port, 7 is giving you 1. So if I had collected 14 here, that would give me 2. It's not that if I connect here, that will give me 2. Now, source and excitation, if they are at the same port, then in the next network as well, you have to collect them at the same port only. And if source and excitation are at the different port, source here, excitation there, then you can interchange the ports. Okay, then you can apply source here and excitation there. So this I have proved in my class notes as well. You can see that class notes, it's available on YouTube only. You can see reciprocity theorem by Himanshu Agarwal. There you can see the proof as well. We have taken the examples as well. There you can see why we cannot do this thing at the different ports. So I1 is something that you cannot determine. Answer of I1 will be can't determine. Okay, and I2 you can determine by simply applying the theorem. That would be I2 will be 6 ampere. Okay, so this is very important, which is missed by a lot of students when they study reciprocity theorem. They do not know the meaning of reciprocity theorem. Okay, so I hope you must have understood now. Thank you. In this problem, you need to find RTH from here. So what you will do, you will apply a VDC and get out IDC out of it. So I can apply VDC here, or I can apply Vx only. So if I apply Vx here, I can get Ix out of it. So my RTH would be Vx by Ix. I need to find the ratio of Vx by Ix. So this node is Vx only. Okay, so Vx by 2 kilo ohm, this current plus this current plus Vx by 2 kilo ohm is equals to Ix. There is no use of this KVX, right? You need to apply nodal here. So Vx by 2 kilo ohm plus Vx by 2 kilo ohm is equals to Ix. That's it. So what is RTH? 1 kilo. So RTH is 1 kilo ohm. That's it. Right? Very simple question it was. Now this is a good question. What they are asking in the circuit shown, this A and B, this branch is replaced by a voltage source. So what they are asking? Are they asking Thevenin voltage? No, they are not asking Thevenin voltage. The particular branch is replaced by V sub. So what they are asking? If this is ground, then they are asking the potential of this point. That's it. Are you getting this point? In a particular circuit, I replaced one branch by a voltage source. I can replace that by a voltage source only when this particular branch was having that particular voltage source. That means this branch would be having V sub voltage source here, V sub voltage here. So I can replace I just replace that branch by V sub voltage source. That's it. So they are not asking you the Thevenin voltage. They are asking you the voltage here. So this V, if I call this as V, this V would be equals to V sub. So you need to determine the value of V. That's it. By simple network analysis, you need to determine the value of V now. This is your task. Let's determine the value of V. So V minus, what I will do is that, okay, there is Ix here, so I cannot do anything much. So I will have to assume this as X. I will assume this as X potential. What is your X potential? X potential is 8 minus Ix. Do you agree? X potential is 8 minus Ix. Ix I am considering to be in milliampere. Ix is in milliampere. So X potential is 8 minus Ix, right? And if I apply nodal at V, so what that would be? V minus X. V minus X means 8 minus Ix. 8 minus Ix. V minus X divided by 1K plus V minus Ix plus V minus Ix. V minus Ix divided by 1K plus V minus 2 by 2 is equals to 0. Everything is correct. In these kind of problems, if you are applying nodal, you should always recheck V minus 8 minus Ix, okay, V minus Ix by 1, V minus 2 by 2. Well and good, everything is correct. So 2.5 V I am getting here, minus 8 plus Ix plus V minus Ix and minus 1 is equals to 0. This V is not coming, this V will not come. So basically 2.5 V is equals to 9. So V is equals to 9 by 2.5, or you can say 5 by 2. So 18 by 5, that would be equals to 3.6 volt. That's it. So answer is B. So the important point was they were not asking you the Thevenin voltage. They were just asking you the voltage on the branch. If this node is 0, then the voltage on the branch will be V only, and that is equals to V sub. So this is what they were asking. Now this is a good question. What you need to do? You need to determine the value of I in the second circuit. So there is no other way. We have to assume a circuit. We have to assume a circuit, right? So from 20 volt 4 ampere current is going. That means here must be 5 ohm resistance. There must be 5 ohm resistance. From 20 volt 4 ampere current is going. That means there must be 5 ohm resistance. So this is the 20 volt battery, right? 20 volt battery, 4 ampere current is going. That means it has to see 5 ohm resistance. And now this 4 ampere current is being divided into two parts. 4 ampere current is being divided into two parts. Effectively, it has to see 5 ohm resistance. That means, and 4 ampere current is being divided into two parts. That means it should be 10 ohm and 10 ohm. 10 ohm and 10 ohm. And this is the short circuit path. So what would be the current? 4 ampere. And what would be the current here? That would be 2 ampere. 4 ampere will be divided in two parts, 2 ampere and 2 ampere. So this current would have been 2 ampere. So what is our network? This is our network. This is our network. This is our network. What is this node? This node is BB dash. This node is BB dash, and this node is AA dash. AA dash. This node is AA dash. So what they are doing at AA dash here, from AA dash 10 ohm resistance is connected. From AA dash 10 ohm resistance is connected. And here this is your AA dash. AA dash. You need to see the port as well. This port they have interchanged. So this you need to take care. This is your AA dash. What they want? They want this current. What is this value? This value is 10 ohm. What is this value? This value is also 10 ohm. At BB dash you are having 40 volt. At BB dash you are having 40 volt. Well and good. Now what is the current flowing? What is the current here? If I call this as Ix current, so what will be your Ix? Ix would be 40 by 15, because 10 parallel will give you 5, so 40 by 15. And what will be your I? I will be half of 40 by 15, but there will be a negative sign because the current is flowing in this direction, so there will be a negative sign. So minus 20 by 15 you can say, or minus 4 by 3 ampere. Answer is minus 4 by 3 ampere. So answer is option 2. So in these kind of questions, there are no other way, no other shortcut. You have to determine, you have to think of a circuit only. So how did I think that 5 ohms should be there and current is being divided? So this is how I thought. Okay. Yeah. So this is a very good question. What you need to determine? You need to determine this potential, this potential. So always if there are two circuits made, what did I tell you? The most important thing is you need to, first you need to see what you need to determine. So what you need to determine? You need to determine this potential. This is our target. That's it. This some potential V. Now what do you think? What is this potential? What do you think? What is this potential? Is this a Thevenin voltage or equivalent voltage? Whatever it is. What do you think? What it is? Isn't it a Thevenin voltage? Right? Because what is Thevenin voltage? Thevenin voltage is the open circuit voltage. You have to open circuit the load. It is already open circuited, and then you need to determine the voltage. And input source should not be shorted. Input source should not be nullified. Input source is there, 10 volt is there, it should not be nullified. 10 volt is already present there. Load should be open circuited and source should be present, and that is there. So that's it. What you need to determine? You need to determine VTH. And what VTH is equals to? I Norton into RTH. So we will try finding I Norton and RTH or directly VTH. But I don't think I can directly determine RTH from here. Sorry, I don't think I can directly determine VTH from here. Right? Because there is no open circuit mentioned. I need to determine VTH. I will take help of this figure now. because both of these networks are same. So now I can take help of this figure. So I need to determine VTH, that means I need to determine open circuit voltage. So I don't think there is any open circuit voltage here. So I cannot directly determine VTH. So I will take the help of Norton current and Thevenin resistance. So first let's find the Norton current using this particular diagram. So directly if you see from here, so what will be the Norton current? If you need to draw the Norton current for this one, let's go to the next page. What will be the Norton current? So for getting the Norton current, what you will do, you will short circuit this. This will be gone. You will short circuit this, and this will be your Norton current, right? This will be your Norton current. So you need to determine this current. So now using the help of this, if 20 volt was applied here, 2 ampere was flowing here. And if 10 volt is applied here, how much current will flow here? 22, 10, 1. So the current is 1 ampere. So your I Norton is 1 ampere. Right? Now if you need to determine RTH, so what you will do? If you need to determine RTH, for determining RTH, how will your circuit look like? Where you need to determine RTH? At this particular node. Here you need to determine RTH at this particular port. So if you need to determine RTH, what you will do? You will apply some VDC and get IDC out of it, right? And if you get IDC out of it, after that what you will do? You will short circuit the input source as well. So if BB dash port is shorted, I apply some BB dash port is shorted, I apply some voltage and get current out of that. So if my VDC was 20, let's just say if my VDC was 20, then what would be my IC? That would have been 10 ampere. This circuit and this circuit, aren't those looking like the same? First I found I Norton by using the reciprocity theorem, because 10 would give me 2, so 20 would give me 2, so 10 would give me 1 here. So I Norton I determined. Now if I see the equivalent circuit here, so what is my equivalent circuit? Equivalent circuit would look something like that. I have to short circuit the input source. So if I apply VDC and get IDC out of it, I applied 20 volt, get 10 ampere out of that, and this branch is shorted. So similar thing is happening, 20 and 10 ampere. So what will be my RTH? RTH will be 2 ohm. So RTH is 2 ohm and IN is 1 ampere. So what will be my VThevenin? VThevenin will be I into R, that means 2 volt. That's it. So this is the perfect answer of this problem. Okay, so the answer is 2 volt. So it was very simple, but how you should approach this problem, that was the main motive behind taking this question. That you should first consider what you need to determine. This I need to determine what that would be equivalent to. If these two things I need to determine, then how will I determine what will be the equivalent circuit? This will be the equivalent circuit, and how will I determine IN value from this particular circuit? So 20, 10, so in this manner. So this was the complete solution. Let's see the solution of this one. So this is a good question. So 4 ampere current is there can be multiple ways. So let's see the simplest way. So 3 ampere current is coming here, 4 ampere current here. So this current would have been 1 ampere, right? Because 3 plus 1 would be 4 ampere. Now if this current is 1 ampere and this current is 1 ampere, that means from here 2 ampere current would have been flowing, right? This would have been 2 ampere, so 1 and 1. So answer would be minus 2 ampere. This is the answer, minus 2 ampere. Ix is minus 2 ampere. Now what can be other way? This current is 4 ampere, this current is 1 ampere. So 2 ampere current would be going here, right? Because 4 ampere and 1 ampere, 5 ampere, 3 ampere is going here, so 2 ampere would be going here. So if you see the ground, from the ground 3 ampere current is getting out, 2 ampere current is getting in, and 2 ampere current is getting out, and 3 ampere current is getting in. So whatever the current ground takes, it has to deliver the same current, right? Let's just say this is the circuit. Let's just say if this is taking 3 ampere current, so ground will deliver the same amount of current. So how much current ground is delivering? 5 ampere. How much current ground is delivering? This is 2 ampere current is taking, here 2 ampere it is delivering. Okay, yeah. So how much current ground is delivering? 5 ampere. 5 ampere. And how much it is taking? 5 ampere. So it is like KCL is correct. What KCL says, whatever the ground delivers, it has to take the same amount of current. So KCL is correct here, right? So KCL is correct. So 5 ampere minus 5 ampere, answer would be minus 2 ampere. So basically you could have, if you know this current, you could have just assumed this current to be X. Then you could apply the relation that whatever the ground takes, it will deliver the same amount of current. So from there also you could get the answer. But this is also a good method to solve. Just by 3, 4, this would be 1, and 1, 1, this would be 2. That's it. Okay. Let's solve this question. This question is framed by me only, and I know many of guys must have got this answer to be wrong. They must have got answer to be minus 1 ampere. This is wrong. And why did you get this? Let me tell you. So what did you do? When only 4 volt was working, if the power was 4 watt. 4 volt was working, the power was 4 watt. So current because of 4 volt, this is what I am writing. Into resistance R, R is 1 ohm. R is 1 ohm. So the power is 4 volt. So the current because of 4 volt battery, that is 2 ampere. I am not talking about the direction of the current now. Okay, the current is 2 ampere. Current because of 4 volt. Similarly, what will be the current because of 9 volt? You can do the same thing. That would be under root power because of 9 volt, right? Because the resistance is 1 ohm only. So what that would be? 3 ampere. We don't know the direction yet. So we know two currents in the resistor. 2 ampere and 3 ampere. Now one more thing is saying, when only Vx source is working, at that time the current flowing through 1 ohm resistance is 1 ampere, and the direction is also fixed, that is from node A to B. Node A to B. From node A to B, 1 ampere current is flowing. This we know. We don't know the direction of these two. What else we know? The total power registered in the total power dissipated in resistor R is 16 watt. The total power P total is 16 watt. P total is 16 watt, which is equals to I net square into R. Whatever the I net current is flowing in this one into R, right? This will be equals to 16 watt. So I net is 4 ampere. I net is 4 ampere. Do you agree to my point? The total current flowing in this branch is 4 ampere. Total current I net, that is 4 ampere. Again we don't know the direction. The current is 4 ampere in this branch, in this particular branch. Now tell me one thing. You know one current is flowing in this direction 1 ampere. How 2 ampere and 3 ampere should flow such that the total current is 4 ampere? What do you think? How this 2 ampere and 3 ampere current should flow such that the total current is 4 ampere? For total current to be 4 ampere, what should happen? 2 plus 3 minus 1. This is the only way. You are given 3 numbers, 2, 3 and 1. You need to get 4 out of it. How will you get? Add these two and subtract. That's it. Right? Got my point? So 2 and 3 has to flow in the same direction. They cannot flow in this direction, because if they flow in the same direction, all will be added. 2 plus 3 plus 1. The current would be 6. But you need current to be 4. So you have to use your brain. These two currents should flow in the opposite direction. So these currents were actually from B to A. From B to A. Right? Now what they are defining as I1? I1 is the current. I1 is the current defined as the current flowing through the resistor R when only 4 volt is working. When only 4 volt was working, what was the current? Current was 2 ampere. But I1 is defined as the current that is flowing from node A to node B. I1 is defined as the current that is flowing from node A to node B. But what is your actual current? Actual current is flowing from node B to node A. So what will be your I1 value? Minus 2 ampere. Say yes or no? The thing is, from A to B, this is your I1 current. And actually your current is flowing in this manner, that is 2 ampere. So what is the value of I1? I1 is minus 2 ampere. That's it. Your actual current is this. Your actual current is flowing in upward direction. And your I1 is defined as this. So I1 will be minus 2 ampere. And similarly, I2 will also be minus 3 ampere. Right? So I1 minus I2 will be what? I1 minus I2 will be what? Minus 2 plus 3. That means 1 ampere. So this was the catch here. Many people would have done 2 minus 3 minus 1. There they must have got it wrong. So you should have the patience. This question was based on the superposition theorem of power. Right? Okay then. Thank you. Let's see the solution of this problem. Here you need to find the V naught value at t equals to 0 and at t equals to infinity. So if you do this question with Laplace transform, it will take a lot of time. But how you will do it intelligently? So what you will do? You will draw the V in waveform, right? V in waveform. Initially it is at 0 because at t equals to 0 you will get 0 and at t equals to infinity you will get 5-fold. This I am drawing input waveform. This is the input waveform. This is your input waveform. From 0 to 5-fold it is going. So at t equals to 0, when your input is 0, at t equals to 0, your input is 0. So what will be your V naught? V naught will also be 0, no? Because there is no voltage. There is no voltage. And at t equals to infinity, what will happen? At t equals to infinity. It is lagging, I don't know why. At t equals to infinity, capacitor will be open circuited. What is your input voltage? At t equals to infinity, what is your input voltage? Input voltage is 5-volt. And capacitors will be open circuited, right? Because at t equals to infinity, capacitor acts as open circuit. That means they have reached their maximum voltage. So if they have reached their maximum voltage, that means if capacitor is open circuited, what does that mean? That V naught value at t equals to infinity will be 5-volt. Because if capacitors are open circuited, this is how the circuit will look like. Capacitors open circuited. So this is how your circuit will look like. So here you are having 5-volt. This is the circuit at t equals to infinity. This is your capacitor and this is your V naught. So V naught at infinity, that would be 5-volt only. So what is the answer? 5. Answer is 5. That's it. Okay. So let's see this question. There are 4 questions. So it is a very good question. Okay. So let me first draw the circuit. Yeah. So this is the circuit. How did we get here? Why did I write 550 here? Here it was showing 5 ampere. Why did I write 550? Because switch was opening at t equals to 0. Initially the switch was closed. These kind of questions we have seen in class notes only. Initially it was closed. So it was closed, then 5 ampere was flowing here. Then if it is open at t equals to 0. Just as it is opened, I will flow to this circuit, this much of circuit. I current will be fed to this much of circuit. Just as when the switch opens. So switch is opening at t equals to 0. That means the current will be fed to this circuit at t equals to 0. At t equals to 0. That means the current can be taken as 550. So the current is 550. Now what they are asking, which is the first question? Find the voltage V naught at t equals to 3 seconds. V naught you need to find at t equals to 3 seconds. Tell me one thing now. If this current is 5 ampere, okay, 550. If this current is 5 ampere, now what will happen? This current will be divided into these two parts, right? Some I1 current can go here, some I2 current can go here. Then again I1, I2 will add up. This is your I2, this is your I1. So 5 is divided into I1 and I2, right? Now here again I1 and I2 will add up, and again this current will be 5 ampere. So yes or no? And always, what does this current source shows? What does this current source shows? That always there will be 5 ampere current. That means through this capacitor there will always be a 5 ampere current source. Are you getting this point or not? Through the capacitor there will be always a 5 ampere current. No one can change it. This is not a RC circuit now. This is this circuit. For the first question, 5 ampere current source is there, that is always flowing through the capacitor. Did you understand this point or not? This was the best thing about the first problem. This question is framed by my own only. No one can claim that I have copied this from anywhere. This question is framed strictly by my own only. So this is what is happening. 5 ampere and 5 ampere. Okay. So what will be your V naught? V naught T. What will be your V naught T? V naught T will be simply be 1 by C integration I dot dt, because current is constant. Current will always be constant. Always 5 ampere current will flow. So 1 by C. C is 3 farad. I dot dt. 5 into dt. And current source was fed at t equals to 0. So from till time t we can calculate. So it would be 5t by 3. Basically it by c, 5t by 3. So at what time they are asking? They are asking at 3 seconds. So what it will be? 5 into 3 by 3. That would be 5 volt. 5 volt. So answer is C. Find Vs at 3 seconds. What you need to find? Vs at this 3 seconds. You need to find Vs. This is the potential Vs. So we know the V naught T. We know V naught T. Right? We need to determine V1T. We need to determine now V1T. So now let's see how can you determine V1T. So what do you think what will happen? This 5 ampere current is there. Now it is being divided into these two parts. So 5 ampere current 5 ampere current is fed to this parallel combination of RC. Say yes or no. Have you seen this kind of circuit? 5 ampere current is fed to this parallel combination of RC. So initially the capacitor can act as short circuit. Say yes or no. This capacitor and both of the capacitor, because at t equals to 0, V0 value is also 0. So initially this capacitor can act as short circuit. So completely 5 ampere current it will take. Complete 5 ampere current capacitor will take. So your V1 at t equals to 0 plus will be 0 volt. This was the answer of first one. This is the answer of second one. So V1 at t equals to 0 plus will be 0 volt. Because complete 5 ampere current this 2 farad will take. At t equals to infinity, what will happen? Look, just as this capacitor has taken some current, then what will happen? It will develop some voltage. Let's just say it has developed some 0.2 voltage. I am giving you the actual thing, what is happening. I am telling you what is actually happening in the circuit. Otherwise, at 0 at infinity, by that also you can solve. Let's just say some current flow, and if some current flows, that means this will take some voltage. If some current is flowing through the capacitor, that means it will develop some voltage. Now the same voltage is there across the resistor as well. 0.1. Now if there is some voltage across the resistor, that means it will drive some current. Say yes or no. Let's just say it is driving 0.1 by R. Okay. So now the resistor has started driving some current. That current is 0.1 by R. So how much current will flow from the capacitor? Initially 5 ampere current was flowing. At t equals to 0, let's just say I call this current as IC. So at t equals to 0, plus IC current was 5 ampere. Right? Whole current was flowing because capacitor was acting as short circuit. After some time, let's just say X plus, after some time, what is the current? 5 minus 0.1 by R. 5 minus 0.1 by R. So the current is going down. The current became low. Still the current is flowing in this direction only. So that means voltage will again develop. Let's just say voltage had developed to 0.15 volt. So how much current this resistor will drive? 0.15 by R. So what will be the current in the capacitor? Current in the capacitor will be 5 minus 0.15 by R. So current has gone more low. So slowly what is happening? The capacitor is losing its current. At steady state what will happen? The capacitor current will be 0 and the whole current will be taken by the resistor. The whole current will be taken by the resistor. So at steady state, capacitor will lose all the current and whole current will be taken by the resistor. So if whole current is taken by the resistor, that means resistor is driving 5 ampere current. Resistor is driving 5 ampere current. So what will be the voltage drop? 10 volt. 5 into 2. 10 volt. So here voltage is exponentially rising from 0 to 10 volt. Say yes or no. Did you understand this point or not? Here it is a first order circuit. This one is first order. What was the response here? Linear. Can't say linear because it is not defined for t less than 0. But it will be a straight line passing through origin. What will be the response here? Here R and C are in parallel. Initially whole current is taken by the capacitor. Then slowly resistor is developing some current. Why it is developing some current? Because there is some voltage across the capacitor. And the same voltage is exposed to the resistor. And if same voltage is exposed to the resistor, that means it will drive some current. So capacitor will start taking lesser current. Because from here 5 ampere current only will come. From this side, from left side 5 ampere current only will come. So capacitor is losing its current and resistor is developing some current. At steady state, capacitor will have 0 ampere current only and resistor will have 5 ampere current. You will be able to understand it if you have studied network analysis from PrepFusion. I know you wouldn't like this statement, but yeah, these kind of good questions, this kind of good intuition will come only if you study transient analysis from PrepFusion. Otherwise, no one teaches these kind of concepts and I know them. Okay, so yeah. So from 0 to it has developed to 5R. From 0 to 5R, 5R you can say or 10 volt. This is your V1T waveform. So your V1T waveform is 10 volt it has gone e to the power minus t by tau. Can you tell me the time constant? In time constant there is no role of this capacitor. Or you can find time constant in the manner only that tau equals to R into C equivalent. So across the resistor, what is the capacitance you see? Only 2 farad only, not this 3 farad. Because current source will be open circuited. So this 3 farad will not come in action. So across the resistor, 2 farad only is there. So 2 into 2, 4 seconds. Time constant is 4 seconds. So here time constant will be 4 seconds. Okay, so this is the V1t waveform. So basically your V1t waveform is coming tan into 1 minus e to the power minus t by 4, and your V0 t is 5t by c, so that would be 5t by 3, 5t by 3, and your VST is simply V1t plus V0t, right? So what you need to find Vs at 3 seconds. So let me calculate the value. So what we are getting 10.27 volt. Okay, so this is the answer of the second question, that is 10.27 volt. Now let's see the third one. Let your transfer function be V1s by I in S. What is the order of the circuit? V1s by I in S. What is the order of the circuit? First order, right? What is the order? First order. Because here R and C are in parallel. You can apply Laplace transform, you will get to know it is first order only. V1s by I1s. The transfer function, the order of the circuit is always defined with respect to the output and input. It's not defined with respect to the circuit. You must have seen teachers saying that what is the order of the circuit. Nothing like that. First you need to tell me what is my output, what is my input. If my output is this one and my input is this, then my order is first order. And if my output is this, if my output is this and input is this, so in the next question as well you will see that your order will never depend on the circuit only. You need to see what is my output, what is my input. With respect to different output and different input, your transfer function will be different. And if your transfer function is different, that means your order is different. Say yes or no, right? So now for this one it is first order. Now let your transfer function be V0 s by I in S. What is the time constant of the circuit? RC. Time constant of the circuit RC, R1, C1 plus C2 or anything like that. No, time constant is infinity here. And you can calculate as well. What you will do? You will make this current source as open circuit, right? You will make this current source as open circuit. So what is the equivalent resistance you see across this capacitance? Tau is equals to RC, right? RC equivalent or R equivalent you can say. What is the equivalent resistor? Infinity. Resistance is infinity. Say yes or no? This is a single capacitor only. From here, what is the resistance you see? Because current source is open circuited now. So resistance is infinity. So time constant will be infinity only, right? Or you can see from the waveform. If the voltage is constantly rising, this is your V0t waveform. Your voltage is constantly rising. That means it is never reaching the steady state. Your voltage is constantly rising. That means it is never reaching the steady state. And if it never reaches the steady state, what does that mean? The time constant is infinity. If it reaches steady state at t equals to 0 only, that means if it reaches steady state immediately, that means time constant is 0. And if it is reaching steady state at infinity, that means time constant is infinity, right? Because time constant defines the speed of the circuit. What is the speed of the circuit? It is never reaching the steady state. That means it is keep on going. So time constant is infinity, right? So here I will just write never reaching steady state. Time constant is infinity. So this is the complete explanation of the whole circuit. I hope you must have understood. 5 ampere current source will always be there across 3 farad capacitor. So 5 ampere current will always be flowing through 3 farad capacitor. So the response will be a straight line rising from the origin. For 2 ohm and 2 farad, first the current will flow from the 2 farad. 2 farad will develop some voltage. That voltage will be developed across the resistor as well. The resistor will drive some current. So from the capacitor, slowly the current is decreasing, and from the resistors the current is increasing. So with that we will write down the V1 equation as well. Now some people will say that, sir, initially the whole circuit will be shorted, right? And if initially whole circuit is shorted, that means there will be infinite current flow, because in the chapter when you told us that initially if whole circuit is shorted, that means there will be infinite current, and the capacitor will change their voltage instantaneously. Will there be infinite current here? The current will be infinity if there is a voltage source. There is a current source now. There is a current source. So what if I say I make this circuit and I ask you what is the current here? You will say the current is I ampere, I not ampere. No matter whatever the voltage is there across the current source, it can always drive any amount of current. If I naught current is there, if the current is of I naught current, then it will drive I naught current no matter how much voltage is there across the current source, right? So even if there is 0 voltage, it will give 5 ampere current only. So there is no infinite current. Infinite current was there because of the voltage source. V divided by the resistance. Resistance was 0. So that's why there was an infinite current, and we changed the voltage across the capacitor immediately. But in this case, it will not happen because the current is finite. Current is finite. You always have to check if the current is infinity or finite. Here the current is finite, not infinity. Okay. So yeah, that's it. So this was a very good question. I hope you have understood every aspect of this. So let's see the solution of this problem. Here you need to find the steady state voltage V0. Okay. So at steady state, what will happen? Both of the capacitor will act as open circuit. So if both are acting as open circuit, that means what will be the current here? Current here will be 2 ampere, and if there is current 2 ampere, so this will be 8 volt. Now this 8 volt will be divided in the inverse proportion of 3C and 4C. Right? It will be divided in inverse proportion of 3C and 4C because capacitors are acting as open circuit. They are not actually open circuited. They are just acting as open circuit. Right? So V0 at infinity, that would be 3C by 4C plus 3C, 7C into 8 volt. So that would be 24 by 7 volt. So answer is B. Right? Okay. So this was very easy. So yeah, let's see this question. So a lot of guys must have solved this with the Laplace transform. And one more thing, here you cannot apply initial value theorem. Why so? Because you will be having an impulse. In V0 you are having an impulse. You need to find V0 value at t equals to 0 plus. So initially you are having an impulse here, so you cannot apply initial value theorem. I hope you know the limitation of initial value theorem. The limitation of initial value theorem is that you cannot have an impulse. In V0 you cannot have an impulse. This is the limitation, right? So we can do the Laplace transform as well. Let's do the Laplace transform. Then I will give you the intuition that how I will solve without any equation. So that intuition I will give you, but let's solve with the Laplace transform first. So method 1, which everyone must have solved with, but you cannot apply here initial value theorem. That we will see why you cannot apply. So what will be your V0? Your V0 t will simply be Ls. Ls is S only upon 2s parallel with 3 ohm. 2s parallel with 3 ohm, right? 2s parallel with 3 ohm will give me 6s upon 2s plus 3. So s plus 6s upon 2s plus 3, right? So s I can take common. S if I take common, so it would be 1, and 2s plus 3 will go upward. 2s plus 3 will go upward, and 2s plus 3 plus 6, so it would be 2s plus 9. So what you can say, 2s plus 9 minus 6 divided by 2s plus 9. If you solve it, what you will get? And into 5 also will be there, because V0 t I am calculating. So I just found the transform equation, but I need to multiply with 5 as well, because what is that Laplace transform of 5 delta t? That is 5 only. So this will be 5, and 5 is also multiplied. So what you are getting? 5 1 minus 6 upon 2s plus 9. So what did you get to know? Here you are having an impulse, that is delta t, 5 delta t, and from here 3 by s plus 9 by 2. So your V0 t, what you are getting? In V0 t you are getting, basically I should not have converted it here. Let's keep it as it is. 5 and 3 I am taking common, so what I am getting? 5 minus 15, 5 minus 15 e to the power minus 9 by 2 t. 5, not 5, it would be 5 delta t, because I am taking inverse Laplace now. I am taking inverse Laplace. This was your V0 s. Actually, this was your V0 s, sorry. So now I am taking inverse Laplace, so this would be 5 delta t minus 15 e to the power minus 9 by 2 ut. So at t equals to 0 plus they are asking, not at t equals to 0. At t equals to 0, this will be there, but at t equals to 0 plus, this will not be there, this will be gone. At t equals to 0 plus. So at t equals to 0 plus, this will be gone. So what will be your V0? V0 t at t equals to 0 plus. At t equals to 0 plus, your V0 t is minus 15 volt only. Well and good, very easy. There is no doubt about this question, right? But let's see the method 2, because I need to give you the intuition without applying Laplace transform. So what I would have done? Initially, what will be happening with the inductors? It will be open circuited, right? Inductors will be open circuited. Now we will see what happens later on, but initially inductors will be open circuited because they are not having any current. So initially they are open circuited. This is 5 delta t. Three ohm is there. Now this complete 5 delta t will come here, because if inductor is open circuited, this inductor is open circuited, that means there is 0 ampere current. If there is 0 ampere current, that means this complete 5 delta t will come here. So inductor is which inductor? 1 Henry inductor. 1 Henry inductor is exposed to impulse voltage. And I told you one thing, if there is impulse voltage across the inductor, if there is infinite voltage across the inductor, that means it will change its current instantaneously. Inductor generally does not change its current instantaneously. If at t equals to 0 minus it is 0, then at t equals to 0 plus it will also be 0. But only in the case of infinite voltage or impulse voltage it will change its current instantaneously. What was the case in case of capacitor? In case of capacitor, if there is infinite current, then it will change its voltage instantaneously. And in case of inductor, if there is infinite voltage, then it will change its current instantaneously. So this was a very basic thing which we have studied in transient analysis, right? And you can prove it as well. The proof is already given in the transient analysis chapter, so you can go and watch there. This has been uploaded on YouTube only. So yeah. So what will be the current? What will be the current? Current expression for inductor, that is 1 by L integration v dot dt from any time limit you can take. Basically, so 1 by 5 ampere current. Basically, you will develop 1 by L is 1 only, and this is 5 delta t. So 5 delta t, and you will do the integration. So you will get to know that you have developed 5 ampere current. So suddenly you have developed 5 ampere current in this inductor. 5 ampere current. So at t equals to 0 plus, what will be the circuit? Can you tell? At t equals to 0 plus. At t equals to 0 plus, this will be gone. Say yes or no. At t equals to 0 plus, your voltage source will be gone. At t equals to 0 plus, your V in t is 0. 0 volt. This is 0 volt because impulse is already there at only t equals to 0, not at 0 plus. This is the function of impulse. This is 5 delta t. At t equals to 0 plus, it is not there. So this has gone now. This has gone, right? So this has gone. Input is gone. This inductor was not having infinite voltage, so it will not change its current. It will drive 0 ampere current only. This inductor was not having infinite voltage, so it will drive 0 ampere current only. So this inductor will be acting as open circuit only. Infinite voltage was there across this inductor. Now this inductor is driving 5 ampere current. This inductor is driving 5 ampere current. Now what they are asking? The value of V0. What is V0? This is your V0. This node is grounded and this is 3 ampere current. 3 ohm, sorry. This is 3 ohm. This node is grounded. This 5 ampere current will flow through this resistance as well. Say yes or no. Because it does not have any other path. At t equals to 0 plus, we are having 5 ampere current in this inductor. Now this current cannot flow from 2 Henry because 2 Henry will say there was no infinite voltage across me, so I will hold my current. So its current was 0 ampere initially. So it will take 0 ampere current only. So 5 ampere current will flow through this resistor. So 5 ampere is flowing through this resistor and input is already gone. So if 5 ampere is flowing through this resistor, then what is the value of V0? V0 will be simply minus 3 into 5, right? This voltage drop will be there, that will be 15 volt. So minus 3 into 5, V0 will be minus 15 volt at t equals to 0 plus. So that's it. This is the intuition. By the intuition, in 1 second only, if I had seen this circuit, I would go to know, okay, 5 ampere current is flowing through the resistor, it will flow. 5 into 3 minus 15, that's it. No these kind of things, no initial value setup, no final value setup. If you have good intuition, if you have studied deeply network analysis, there will be no problem in control systems, there will be no problem in analog electronics, there will be no problem in signal systems, there will be no problem in your whole electronics and electrical subjects. That's why I have given the subject freely on YouTube, and I have taught in that manner that forget about comparing with anyone. You will not find these concepts in the books as well. In any textbook you will not going to find. Okay, so these kind of concept has been delivered, and if you are not watching those videos, it is your loss. Okay, it might seem harsh to you, you might feel that I am just bragging it, but the kind of content is there. Once you watch it, you will realize it. Okay, then let's see the next question. So let's solve this question. What you need to find? You need to find the order of the circuit. 3 capacitors, third order. 3 capacitors are there, so third order circuit it is. No, it's not third order, it is first order only. What is the current from here? 0 ampere. This will drive 0 ampere current. How do you find the order of the circuit? I told you, you have to give independent voltages. If I give independent voltage V1 to this, okay, there is 5 volt is there. Can I write the potential across C2, C1 and C3 directly from the 5 volt? No, because there is a resistor in between. So I have to give independent voltage to one of the capacitors. If I give independent voltage V1 to this capacitor, can I write the voltage across these two capacitors? in terms of V1 and 5 volt, because I need to write the voltage across the capacitor in terms of the known voltages. What is the known voltage? 5 volt and V1. Can I write down the voltage across capacitor C1 and capacitor C2 in terms of the known voltages? Yes, I can write. What is your VC1? VC1 is simply C3 upon C1 plus C3 into V1. That's it. And what is your VC3? VC3 is C1 upon C1 plus C3 into V1. So you have to give only one independent voltage. There was only one state variable. Do you know what is a state variable? State variable. Only one state variable was there. You have to give from your side, you have to give only one voltage. That is V1. That means there is only one state variable. When you study control system, you will get to know what do you mean by state variable. But in network analysis, you don't even need to use this term. No need to use the term of state variable. You just need to know that there is only one variable, right? Only V1 you had to give from your side. So order is first order. If I draw this circuit, why do we say this is first order circuit? Because I cannot write down the potential across the capacitor C directly, right? I have to give some independent voltage. So order is first order. Why do we say this is zero order circuit? Why do we say this is zero order circuit? Because if this is V in, I know the voltage across the capacitor, that is V in only. So I already know the voltage across the capacitor. I don't have to give any independent voltage source. I don't have to give voltage from my side. That's why it is zero order, right? This is zero order and time constant is also zero. Here time constant is RC. Now this will also be first order. Why this is first order? Because I have to give only one independent voltage. Okay then. Okay, so this concept I have already taught in the course. So you can see the course on YouTube. Okay, or otherwise this was a simple question only. I hope most of the people would have got it right. Okay. What you need to find? You need to find Vxt plus Vyt at t equals to 2 seconds. Tell me one thing again. Is this a second order circuit? It is again a first order circuit. If I am calculating Vxt only, it will be a first order. Why so? Because Rc is directly exposed to the voltage. This is your R, this is your C. Rc. This is your Rc and this is your Vxt. And it is fed with this 5 ut voltage. It is fed with this 5 ut voltage. That's it. So what will be your Vxt? 5 into 1 minus e to the power minus t by tau. Tau is Rc and Rc value is 2. Rc value is R into C value is 2. So this is your Vxt. What about Vyt? Vyt as well, it is directly exposed. This is CR circuit only. This is 0, this is 5 volt, this is C, this is R and this is your Vyt. If you directly see, there will be 0.01% chance that they will involve two capacitors and they will ask you second order circuit. I will ask you in the test series, but in the main examination, with two capacitors, they will ask only first order. You just have to see how it is first order. There is 99.95% chance that even if you see two capacitors or three capacitors, it is still going to be first order only. 99.95% chances I am saying. You can see the previous year questions. They are not asking any second order circuit. Okay. So this is C. This is R. This is 5 ut. So what will be your Vyt? Initially it is at 5 and at steady state it will be 0. So 5 into e to the power minus t by tau. Tau is Rc, which is 2. Now if you add them up, Vxt plus Vyt. You need to find Vxt plus Vyt. Time we will see. At what time we need to find? Time we will see. If you add them up, what you will get? 5 only. If you add them up, you are directly getting 5 volt. So at any time it will always be 5 volt. Okay. It will always be 5 volt. Anytime it will be 5 volt only. If you add them up, it will be 5 volt only. Okay. So let's solve this problem. This is a bit lengthy problem. So in this question, what you need to find? You need to find the energy delivered by the voltage source when the switch is open and when it is closed. So two energies you need to find, then you need to find the relation between them, even Ne2. So a bit lengthy it is. So how do you find the energy? What did I tell you? Always I have told you one thing. From where you need to find the energy? Energy delivered by the voltage source. So you need to find the voltage you already know, and you need to find the current. So our target is to just write the current expression. This was the first condition and this would be the second condition. So what is the current that is flowing out of the voltage source? Okay. So for both of them you can certainly write the current equation. It is very easy. So what is the current equation for the first one? So current equation for the first one would be 5 by R e to the power minus T by RC. Now what will be the current equation for the second one? Can you write it down on your own? There is a video that I have made. Now if I explain it here, it would be very tough for me. Okay, so better I should refer it here. So I will put the screenshot of that video. There you will find how to write the equation of this current here. Okay, so in briefly I will tell you here, then I will put the reference of that particular video. You can go and watch the video. Otherwise you can apply the Laplace transform, you will get to know the equation. But how do you find it intuitively, that also I have told. So initially this will be 2.5 volt, this will also be 2.5 volt, so this will drive 2.5 by R current. This will drive 2.5 by R current. Now this 2.5 by R current would be delivered here and here. Now if from here I current is going, that means from here as well I current is flowing. So initially this 2.5 by R current was there, so this current would have been 2.5 by 2R and this current would have been 2.5 by 2R as well. So this is my I current. So from here I can write down the equation. So initially there will be impulse current, and at t equals to 0 plus this will be this current. Okay. So there will be impulse current. What that impulse current would be? 2.5 into C into delta t, because this has developed instantaneously 2.5 voltage, because there will be infinite current, capacitors will be shorted. So I know a lot of you guys are not understanding this because you haven't studied deeply. So there is no need to be offended for this statement, but this is true. So you are not understanding it, but I will refer a video here that you can go and watch. Okay, I will refer a video. I will post the video and I will get the screenshot from there. So you can go and watch that video. After that you will be able to understand what is happening. Initially capacitors will be shorted. So there will be impulse current. If there is impulse current, then the capacitors will develop instantaneous voltage. And if capacitor is developing instantaneous voltage, that means there would have been impulse current. And how do you find the current? Initially there was 0 voltage across the capacitor. Now the voltage has increased to 2.5 into C, because 5 will be divided 2.5, 2.5. So 2.5 into C, this is the voltage. Voltage has been developed. What is the current? Current is C dVc by dt. The change in capacitor voltage, right? So that would be, current would be 2.5 C into delta t. Okay. So this was the initial charge. This was the steady state charge. So what is the change in the charge? Change in the charge was 2.5 C. And time was 0 only, so 2.5 C into delta t. So the current at t equals to 0 was this one, 2.5 C delta t. And after that it will follow 2.5 by 2R e to the power minus t by 2. Now what is tau for this one? Tau for this one is 2RC into ut, because C and C will come in parallel. So this is the current. Now we just need to find the energy. So what is energy? P into dt. What is P? Vt into it into dt. From minus infinity to infinity you need to find. But all these will start from t equals to 0 only. So we will start from t equals to 0, because ut will start from t equals to 0. 5 ut into 5 by r e to the power minus t by rc dt. If you solve it, you will get 25c. Okay, 25c. For this as well, we remember the answer as well, cv square. It would be 25c joule. Let's solve this one. So how will you solve this one? E is equals to, here the calculation will be interesting, from 0 to infinity, because everything will start from t equals to 0 only, because that impulse also starts from t equals to 0 only. So now 5 ut is there. 5 ut is there. And what is your current? Current is 2.5 C delta t plus 2.5 by 2R e to the power minus t by 2RC ut delta t. Ut and delta t multiplied, what it will give you? 5 into 5 by 2, 25 by 2. 25 by 2. Ut and delta t multiplied, what it will give you? Delta t only, right? Plus, this is 5 by 4, this would be 25 by 4, right? 25 by 4R. This is 5 by 2, 5 by 4, 25 by 4. 25 by 4 e to the power minus t by RC. Ut and ut multiplied will give you ut only. If you do this integration, what you will get? 25 by 2, right? 25 by 2, and C is missing here, so C will come also. 25 by 2C. And what about this one? If you do this integration, so 25 by 4R will come outside, e to the power minus t by 2RC it was, 2RC it was. e to the power minus t by 2 RC, and then 2 RC will come here, right, from 0 to infinity. This will become 1 only, and this will become 25 by 2c only. So if you calculate this, it will also become 25c. You can calculate this thing, right? This 4r and 2r will get cancelled, so it will be 25 by 2 RC, 25 by 2c. 25 by 2c plus 25 by 2c would be 25c, and this will become 1 only. So 25c and 25c both are equal. Both, this was your E1 and this is your E2. So there was a lot of calculation, there was a lot of concept involved as well. So both energies are becoming equal. So answer is first one. Okay. So this was a lengthy problem, I admit it, but a lot of concept has been checked here. The current, then you know the energy equation or not. If you know the energy equation, do you know these calculations or not? So these questions are framed specifically by me only. Even no, not even in the standard textbook you will find these problems. Okay, these are framed by me only, by doing the calculation on my own, by thinking about the problem on my own. So you are not going to find those in textbook as well. So yeah, so a lot of content has been tested here, what you know, and for that I am referring to a video now. So I will put the screenshot of that video here. So this video you need to watch miscellaneous concept of current waveform. Miscellaneous concept of current waveform. So here I have explained how this expression comes with intuition. With the Laplace transform you can find it, right? You will be easily able to find it with Laplace transform, but in 1 second only, or not in 1 second, in 30 seconds I can write the expression directly just by my intuition. 2.5, 2.5, okay, 2.5 C delta T, then 2.5 by R current here, then this would drive 2.5 by 2R current, this would drive 2.5 by 2R current. So this current and this current are equal. Basically from here, how did I write this current? Because this current and this current is equal only. So if I know the current in this capacitor, then the same current will be flowing here, right? So 2.5 by 2R e to the power minus t by 2R C ut. Okay, so from here you could get the final answer. Okay, so do watch this video, it will be helpful for you. Okay, thank you. So let's solve this problem. This is a good problem. The switch is closed at t equals to 0. Find V naught t at 10 microsecond. So if you had solved it with Laplace transform, it would have been very tough to get the answer, because the expression will not be that easy. So how you would solve it intuitively? First tell me what is the order of the circuit? First order. Why is it first order? Because switch is being closed here, so this will be 4 volt. And if I give V1 voltage to this, I can write down the potential here. That would be 4 minus V1. So I have to give only one independent voltage. I have to give only one independent voltage from my side. That means it is first order circuit. The concept behind it we have already seen. What do you mean by independent voltage? What do you mean by state variable? Everything we have already seen in previous videos and also in the concept as well. Okay, so now what we are doing, we are closing the switch at t equals to 0. You need to find V naught at t 10 seconds. So just as we switch the close, what will happen? The inductors are having 0 voltage, right? So inductors will be shorted. If inductor is shorted, then 4 volt will see 0 resistance here, right? If inductor is shorted, 4 volt will see 0 resistance. That means there will be infinity current. So there will be impulsive current here. In the capacitors, there will be impulsive current. And if there is impulsive current, what does that mean? The capacitor will change their voltage instantaneously. I hope you know all these kind of concept. So if there is impulsive current, that means capacitors will change their voltage instantaneously. So what will be the scene across the capacitors? This is capacitor C, this is capacitor C. And here there is 4 volt, right? This is some node, there are some other resistance as well, everything is there, forget about it. Let's just find the voltage across the capacitor. So current will be flowing in this direction at t equals to 0 plus, I am saying at t equals to 0 plus, current will be flowing in this directions. So at t equals to 0 plus, this will develop 2 volt, this will also develop 2 volt, because both of the capacitance value are same, right? This will develop 2 volt and this will also develop 2 volt, right? Because current is flowing in this direction. And now this is the scene, here you are having 4 volt. This is your 4 volt only, and this is 5 kilo ohm. This is 5 kilo ohm, this is also 5 kilo ohm. This is 4, this voltage will be 2 volt. This is 4 volt, this is 2 volt. So what your V naught will be? This all is happening at t equals to 0 plus. Everything is happening t equals to 0 plus. 4 volt is there, 2 and 2 volt is divided. This potential is 2 volt, this potential is 4 volt. So what will be this potential? 4 and 2 here. If you apply the nodal analysis, you will get to know, or directly you can see 4 into 5 plus 2 into 5 divided by 10. So V naught at t equals to 0 plus. Just you have to apply nodal here. V naught minus 2 by 5 plus V naught minus 4 by 5 is equals to 0. So that would be 3 volt. So at t equals to 0 plus, you are getting 3 volt. Are you understanding what happened here? Infinite current was flowing, so capacitor will change its voltage instantaneously. So 4 volt, 2 and 2 volt, and 4 volt is 4 volt goes here. So this would become 2 volt. So this would be 3 volt. Say yes or no. Now at infinity, what will happen? At infinity, what will happen? Inductors will be open circuited, right? Inductors will be open circuited. So inductors are open circuited. everything is gone, there is no current. The all, sorry, not inductor, capacitors. Capacitor will be open circuited, so all the capacitors are open circuited. So this end of this resistance will be open ended. This is 5 kilo ohm. So there is no current here, 0 ampere current here. That means what will be your V naught? V naught will be 4 volt only, right? There will be 0 current through the resistors. So from here 4 volt will reach here. So V naught infinity is 4 volt. So what will be your V naught T? At infinity you need 4 volt, and at 0 you need 3 volt. So it would be 4 into 4 minus e to the power minus t by tau. Now what will be your tau? Can you find tau? Yes, we can find. What we will do with the battery? Battery will be shorted. This is 5 kilo ohm. This is also 5 kilo ohm. This end of this one of the capacitor is here, 1 nanofarad, right? The other capacitor, the other end will be grounded, and this node will be as it is. So other end will be grounded, 1 nanofarad. This is 5 kilo ohm, and the other end of this other resistor is also grounded. This is also 5 kilo ohm, and this is V naught. And 1 in parallel, what it would become? 2 nanofarad, right? And what do you think about 5 kilo ohm and 5 kilo ohm? Are they in series or parallel? They are in series. I know many of you guys get confused how to find series or parallel. So I will tell you a simple method. If you need to find 5 kilo ohm and 5 kilo ohm. So get some current I from any of the resistor. Let's just say I get current I from this resistor. I am saying that I current is flowing in this 5 kilo ohm resistance. Now what is the current that is flowing in this 5 kilo ohm resistance? I only, right? If I get I current from this 5 kilo ohm resistance, then the same current is flowing, right? If this is I, this has to be I as well, because there is no other path. So if both of them are having the same current, that means they are in series, otherwise they are in parallel. That's it. Very, very easy. In some condition, if you see this circuit, let's just say if you see this circuit, here it would be directly very easy, right? Okay, let's check. So here you need to find time constant with respect to this output. Let's just say for this output. So what you will do? First you will open circuit this, right? Now you need to find whether these two capacitors are in series or parallel. Here I can directly see they are in parallel only, but how I could have done it? If I say that I current is flowing here, then what is the current going here? Certainly not I, because this I has two paths. It can go into resistor as well, it can go into capacitor as well. So this I is having two paths. So if both of them are not having the same current, that means they are in parallel. And if both are having the same current, that means they are in series. Very easy, right? So if I say I current is flowing from this 5 kilo ohm, then certainly I current is flowing from the other 5 kilo ohm as well. That means both are in series. And total capacitance is 2 nanofarad. So 2 nanofarad, 2 nano into 5 kilo. 2 nano into 5 kilo. What that would be? 10 micro. 10 micro. So what is your V naught T? Finally, this is the expression of V naught T, which we will be getting very quickly if we have the good enough aptitude of network analysis. If you have studied from a good resource, you will be able to get it very, very quickly. Otherwise, apply Laplace transform, it will take a lot of time, right? So first I will see instantaneously it will be divided 4 and 2 here, so this will be 3. So first I will write down the potential at t equals to 0. At infinity it is very easy, it will be open circuited, so infinity it will be 4 volt. Now I can write down the equation as well, 5 into e to the power minus t by 2. Sorry, 4 into 4 minus e to the power minus t by 2. So after that I will write down the tau value as well. Tau value is also very easy, 5 and 5 comes in series and 1 and 1 comes in parallel, right? So this is how I can write it, then I can solve it. At what time I need to find? 10 micro. How much is e to the power minus 1? It is 0.36. I will just calculate it. 4 minus e to the power minus 1. 3.63 I am getting. T equals to 0, 3 at infinity. It is 4 volt only. 3.63. So there is some issue in the options. Okay. I will modify it. This is the answer we are getting. Okay, so I will modify it. Yeah, hi. So there was a mistake from my side only. 5 plus 5, 10. This would be 20, right? This is 10K. So this would be 20. So here 20 will come, right? And here 20 will come. So 1 by 2 plus minus e to the power and minus 4. So 3.39 I am getting again. Still there is an issue. Time constant is 2 nanofarad, right? 10 into 2, 20 micro. And at 10 microsecond you need to find. So 1 by 2, that means 0.5, 0.5 plus minus e to the power minus 4. So 3.39 we are getting, okay? Roughly around 3.39 we are getting. So this would be the correct one, okay? So let's see this problem. This is a very conceptual problem, and this will clear a lot of misconceptions of yours, okay? So you guys will learn a lot more new things here. So if I ask you what is the order of the circuit, what you will say? What is the order of the circuit? Some guys will blindly say, sir, I will short circuit this and I will see that this 1 Henry and 3 Henry will come in parallel. So it is a first order circuit. That's it. Absolutely wrong. Why absolutely wrong? Because if I am saying what is your order, what is the order of the circuit, what will be your first question? I have told this thing like 100 times. What will be your first question? That sir, first define what is my output and input. Input is this 4 volt and this is your output. If I am saying your voltage is your output and your input is 4 volt, this input source, or 4 ut you can say, because the switch is being closed at t equals to 0, so it is 4 ut only. So if I say this is your input, then you can say that yes, the order is first order. With respect to voltage, it is first order. Why is it so? Because if I say that I am giving V1 voltage to this one, if I am giving one independent voltage to this one, can I write down the potential across this inductor in terms of the known voltages? This V1 I know because I myself is giving this independent voltage. So yeah, I can write down it. How I will write down it? 3 minus V1. So I have to give only one independent voltage from my side. Only one independent voltage from my side. That means it is a first order circuit. Understood? There is only one state variable. So with respect to V naught, it is first order circuit. Okay. But with respect to current, whether it will be first order or not, that we will see in the next question. So with respect to V naught, it is a first order circuit. So it is a first order circuit and they are asking you to find the V naught value at t equals to 1 microsecond. So if it is first order, then we can directly write down the equation. How we will write down? Let's check that out. So for V naught, it is first order. This I am writing. Okay. For V naught, it is first order. So initially, what is the value of V naught? Both inductors will act as open circuit. So V naught value will be at t equals to 0 plus. It will be 4 volt only because both are acting as open circuited, right? So 4 volt will reach there. At t equals to infinity, what will happen? Both will be shorted. So how will the circuit look like? At t equals to infinity. Just a second. Yeah. So at t equals to infinity, both inductors will be open circuited. So how will your circuit look like? Both inductors will be shorted. Sorry. This will also be shorted, right? So the complete circuit is shorted. Complete circuit is shorted here. So how will the voltage be divided? The inductors are acting as short circuit. It is not actually short circuit. Okay. They are acting as short circuit. So it is actually there. So from the parallel combination of inductor and resistor, which is dominating now, since this is a short circuit, so lower resistance, let's just say 0.5 ohm, and R would be some finite. Let's just say it is 1000 ohm. One is very low, one is finite. So which one will be dominating? This parallel combination will come nearly around 0.5 ohm only. So this one will be dominating. So you can replace this parallel combination. You can replace this parallel combination with simple inductor only. Simple inductor, which is shorted. Simple inductor which is shorted. So this is 1 Henry only. If you are saying that my inductor is providing very low impedance, at t equals to infinity, they will be shorted. That means it is providing very low impedance. So very low impedance in parallel to finite impedance. That means it will be very low impedance only. And what about this one? There is nothing in parallel, so it will be replaced with 3 Henry only. So this will be the circuit at t equals to infinity. Okay, this is 4 volt. So what you need to find? V naught at infinity. So this circuit we have drawn at t equals to infinity. So V naught at infinity, what that would be? Simply it will be divided in proportion only. So 3 by 4 into 4, 3 volt. So from 4 volt we are going to 3 volt. Are you understanding this point? At infinity, it will simply be divided in proportion. So it will be replaced, this will be replaced 1 Henry, this is replaced with 3 Henry. So this will be 3 volt, right? So what will be your V naught T equation? We are going towards 3 volt starting with 4 volt. T by tau. What will be tau? 1 and 3 will come in parallel. So it will be 4. So tau is L by R. L by, sorry, 3 and, sorry, 3 and 1 will come in parallel. So it will be 3 by 4 divided by R. R is 1 only. So 3 by 4 second. So it is 0.75. And at what point you need to find? 1 second. 3 plus e to the power minus 1 by 0.75. So let's check that. What I will do in the calculator, I will put 4 by 3, then I will put plus minus sign, then I would say e to the power minus 1 by 0.75 plus 3. So 3.26, that's it. This is the answer. 3.26 volt. So this is the answer of the first question. This is the answer of the first question, that is 3.26 volt. Now let's go to the second problem and let's see what they are asking. If they are asking the value of I naught at t equals to 1 second, is it first order? My question is it first order? Look, what did I get to know that my V naught is, for V naught, my circuit is acting as first order circuit. That means certainly the transfer function would be somewhat like this. V naught s by V in s would be A upon there could be a 0. Let's just say there could be a 0. We are not sure if there is a 0 or not, but certainly there will be only one pole. Say yes or no. This is how my transfer function will look like. Certainly there will be a one pole. So I can write my V naught as A into SZ1 plus SP1 plus 1 into V in S. Now can you tell me what will be my I naught as? What will be my I naught as in terms of V naught S? It will be V naught S by Ls. Say yes or no? Very simple. Current is equals to voltage voltage by resistance. Current is equals to voltage by resistance. Resistance provided by an impedance. Resistance provided by an inductor is Ls only. Let's just say I am calling it L2. Let's just say I am calling it L2. So what would be the impedance? It would be L2S. So my I naught S would be V naught S by L2S. So if I drop my V naught S equation here, if I drop my V naught S equation, what I will get? A into what will be my V naught S? V naught S was 1 0. It could be there, I am not sure. And one pole into L2S into V in S, and this V in S can go here. So if I am saying that I naught is my output and V in S my input, then how many poles are you having here? 2 poles. So what is the order of the circuit? Second order. But one thing you need to make sure that in case of V naught, you should not have a 0 at 0. 0 at 0. Should not have it. If you are having a 0 at 0, let's just say in case of V naught, I was having a 0 at 0, then what would have happened? Here I would be having a 0. Let's just say I am having a 0 at 0. So I can replace this as S. So S and S would have been getting cancelled. Then it would become first order circuit only. In a simple LR circuit, this is what happens. Simple LR circuit. This is your V, and this is your V naught, and this is your I naught, and this is your V in S. This is R, this is L. For voltage also it is first order, for current also it is first order. Why so? Because if you find the transfer function of V naught S, what you will get? Ls upon Ls plus R. You are having one pole, but you are having a 0 at 0. So if you write down the current expression, then what will happen? Ls upon Ls plus R, this is the voltage divided by Ls. So this and this will get cancelled. So here pole 0 cancellation is there, that's why it is first order circuit. So whenever you say that for voltage it is first order, then for current it would be second order. Yes, it would be second order if your voltage is not having a 0 at 0. So at omega equals to 0, are we getting V naught equals to 0? Let's check. At omega equals to 0. At omega equals to 0. That means omega equals to 0, that means it will provide very low impedance. At omega equals to 0, inductor provides very low impedance. This will also provide very low impedance. So at omega equals to 0, this will be the circuit because both are providing very low impedance. So it will be replaced with 1 Henry and this will be replaced with 3 Henry. So this will be the circuit at omega equals to 0. So at omega equals to 0, you are not getting V naught equals to 0. What do you mean by 0? 0 means your output is 0. If you are saying I am having a 0, that means your output is 0. At 0, your output is 0. At pole, your output is infinity. Right? This much basic you know. So you are not getting V naught equals to 0 at omega equals to 0. What does that mean? You are not having a 0 at omega equals to 0. This is for sure that we are not having a 0 at omega equals to 0. This we have understood from here. Then certainly for current it will be second order circuit. Now you will say, sir, how I will be able to think this in all these things in the examination? You will be able to think if you studied it deeply. Okay, if you studied deeply, if you solve all the problems, whatever that I have taught, if you solve those kind of things, you will be able to solve very, very quickly in the examination. And guys, they are spending 15 minutes, you will be spending only 2 minutes. to solve these problems. Okay, so in the first problem only you get to know that it is first order. That's it. In second one you got to know we are collecting the current. So here one zero would come. Sorry, one pole would come at t equals to 0. But I need to make sure in case of V naught I should not have a 0 at 0. So I will check at omega equals to 0 if I am getting a 0. No, I am not getting a 0. That means certainly I will be having two poles in case of current. So if I am having two poles, it would be second order circuit, and intuitively I cannot calculate it. 99.99% chances are there the circuit that is given in your examination, that would be first order circuit only. 99.99%. That would be first order, because in second order you have to apply Laplace transform and it involves a lot of calculation. So they wouldn't want you to do large number of calculations. That's why they will give first order circuit only. Here in the test series I can give these kind of problems, so no need to worry. So now you got to know that it is a first order circuit, sorry, second order circuit. So you just need to apply the equations. Even believe me, even with the intuition you can write down the I naught t expression, but that would be very tough for you. It would be very difficult for me to explain that. In some other video I will explain that how you can write down the second order equation I naught t, which would be second order intuitively here. Okay, so that I will be explaining in some other video. So for current, let's write down the expression. So what that would be? So I naught s, just simple Laplace transform it is. So that would be V in s. V in s is 4 by s divided by the total impedance. Total impedance is 3s plus s parallel with 1 ohm. S parallel with 1 ohm. Right? So 4 by s divided by 3s plus s upon s plus 1. So 4 by s, 3s square plus 3s 4s. So 4 by s square, s will come here, s square would be outside, 3s plus 4. Right? So now we have to do the factorization. Yeah, so this is the calculation part. Actually I missed this s plus 1 here, so this would go upward. So it took me some time to solve this problem. So this s plus 1 would go upward. This would be 4 by s square and this would be 3s plus 4. Then we solve this equation and finally we get this one. How do we do the factorization? How do we do the factorization? Just if this is written as this one, so I can write it as as plus b upon s square plus c upon 3s square plus 4. So from there I could get to know, I can compare the values. So a, b, c value I will get. So I hope you know this basic factorization. How do we do it? So from here what do I get? I will erase these a, b, c value. This is the factorization that we have done. So from here what I am getting? I am getting 1 by 4 ut plus tut, 1 by s square is tut, minus 1 by 3 e to the power minus 4 by 3t, right? Okay, so what I need to calculate at 1 second? So 1 second I will put, although this is very calculative, very calculative, so it must have taken some time for you to solve. So 1 second if I put, it would be 1 by 4 only, it would be 1, and this would be minus 1 by 3 e to the power minus 4 by 3. So 4 by 3 I will do 4 by 3, then I will put plus minus sign, then e to the power, then by 3, then again plus minus sign, then plus 1, and then plus 0.25, 1.16 I am getting. So current value is roughly around 1.16 ampere. Well and good. So this was a good question. I hope you must have understood a lot of new things here. Okay then. Let's solve this one. So this is very straightforward. This is the easiest problem of this complete chapter. I hope you know this concept. Once it will be closed, the capacitor will be shorted. That means capacitor is providing very low impedance. This is providing very low and this is also providing very low. So what will happen? This parallel combination of RC will be replaced with the capacitor only, because very low parallel to finite will be very low only. So it will be replaced with capacitor. This will also be replaced with capacitor. So at t equals to 0, this is how your circuit will look like. C and C. So directly it will be divided 2.5 and 2.5. So V naught value at t equals to V naught. This is your V naught. So V naught value at, yeah, what is this? V equals to 0. V naught. So V naught value at t equals to 0 plus, that will be 2.5 volt. Okay. So these designers need to take care what they are writing. I don't know. V equals to 0. I hope you didn't get confused in this one. Okay, then let's see. Now this is a very interesting problem, and this is somewhat similar to what we have already seen in the previous test series, in the fourth one. So what we are doing here, initially the switch was closed like this for t less than 0, so complete 5 ampere current was flowing here, so no issue about that. Now the switch is open, so 5 ampere will be given here. So for t less than 0, there was nothing happening in the circuit because there was no source. Complete 5 ampere current was flowing through the short circuit path. So 5 ampere was not going here. So circuit was remaining as it is. Now what happened? Now this 5 ampere current is exposed. So how will the circuit look like? The circuit will look something like this. Directly 5 ampere current, then parallel combination of RL and then there is an inductor, right? Tell me one thing, if 5 ampere current is going here, then how much current is going here? Can you tell me? It will also be 5 ampere only, because 5 ampere will be divided between these two, I1 and I2. Then I1 and I2 will be added up and again 5 ampere current will be flowing. So from an inductor there is a fixed current that is flowing, that is 5 ampere. So what will be the voltage? This is your V naught. Although I did not ask V naught, so what will be your V naught? From an inductor fixed current is flowing, V naught, that will be L di by dt. And fixed 5 ampere, this will be 5 ut, right? Because this is applied at t equals to 0 only. So L value is 2 into 5 into ut, that will be delta t. Simply I am doing the differentiation. So tan delta t. So here in this inductor always 5 ampere current will be flowing. That means this will always give you just an impulse at t equals to 0. 5 ampere current flows and there is an impulse, that's it. This is complete. This is your V naught t. An impulse is there. This is your V naught t, but we need to draw VST. So we need to take care of this potential as well. We need to find this potential V1 now. So initially what happens to the inductor? Inductor does not take any current, right? Initially 3 Henry was not having any current. So where will the current flow? The current will flow here at t equals to 0. At t equals to 0. At t equals to 0 plus. Initially inductor was saying that I will not have any current. So the current has to flow here. Now this inductor cannot say that I will not have any current. If this inductor says that I will not have any current, that means your KCL will be invalid. Then where will this 5 ampere current go? 5 ampere current will go. Now it will ask 3 Henry and 1 ohm. 1 ohm will say that I am a resistance, I can take up any current. 3 Henry will say I was having 0 ampere current, so I will take 0 ampere current only. So 5 ampere will say that I will go here. So 5 ampere is going here. Now it will ask only the inductor. If inductor says that I cannot have current, then where will the current go? So inductor has to sacrifice. It has to flow 5 ampere current from it. So 5 ampere current has no other path to flow, so it will flow in this manner only. Say yes or no. Understood this concept? Very easy, right? So so this inductor is having 5 ampere current. This one is having 5 ampere current and this one is having 0 ampere current. So if complete 5 ampere current is flowing here, that means what is the V1 potential at t equals to 0 plus? V1 potential at t equals to 0 plus will be 5 volt, because 5 into 1, 5 ampere into 1 ohm, that means 5 volt. At t equals to infinity, what inductor will say? Inductor will say that I am shorted and this is also shorted. So inductor will say that I will take up all the current. Is that possible? Yes, it is possible. No KCL KVL will be invalid. If inductor is saying that I will take up all the current, so no KCL KVL will be invalid here. Why? Because inductor can take this much amount of current. And what will be the circuit at t equals to infinity? Inductor is saying it will take up all the current, that means it will be shorted. And this will also be shorted because we know that it will give impulse only at t equals to 0 only. So this will also be shorted. Is there any violation of KCL KVL? No. 5 ampere current can flow here. And if you say that, sir, across the current source there is 0 volt, how it will deliver the current? Yeah, it can deliver the current. What is the property of a current source? That it can deliver any amount of current with respect to any voltage. Even if you are having 0 ampere current and the current source is of 5 ampere, then it will give 5 ampere current. No matter if it is having 1 volt, 2 volt, 3 volt, infinite volt, 70 volt, 80 volt, 0 volt, it will always give 5 ampere current. So even if it is having 0 voltage there, then it can certainly give you 5 ampere current. There is no violation of KCL KVL. So no rules got violated and nothing wrong happened here. So certainly here there will be 0 volt only. This V1 potential will be 0 volt because inductor has been shorted. So this will be 0 volt. So what will be your Vs potential? What is your Vs? Vst is equals to V0 V1t. This I am calling as V1t plus V0t. V1t plus V0t. So you need to just add both of the graphs. You need to add both of the graphs. So this was having an impulse like this, 10, right? 10 delta t. Delta t I will not write here. Plus this graph 5 to 0. From 5 to 0. From 5 to 0. So this will be your V0 t. Now tell me the time constant for this one. For this one, what is the time constant? Can you tell me? For this V0 t, what is the time constant? 0. Why 0? Because this is the steady state only. Just as the switch got opened, there was a steady state at output. So immediate steady state was there. So that means time constant is 0. Or how you can check? Time constant is L by R. So L equivalent across the output you can see only 2 Henry. From here, what is the impedance you see? From here, what will be the impedance you see? Current source will be open circuited. Current source will be open circuited. If you apply VDC here, how much current you will get? 0 ampere because no current can flow. Since this is open circuited, so no current can flow. So from here I see infinity resistance. Very simple. Since this is open circuited, there will be infinity resistance. So R equivalent I see infinity. So what is the time constant? 0. So this is the way you can say time constant is 0, or directly if you think that steady state is reached immediately, so that means there will be 0 time constant. And what about this one? What about this one? Here you got to know that in case of this waveform, there is only role of this and this. Only role of 3 Henry and 1 ohm. There was no role of this. This was always driving 5 ampere current. So 5 ampere current was fed to the parallel combination of 3 Henry and 1 Henry. So there was no role of this one. So what will be the time constant? Time constant 2 will be L by R, 3 by 1, 3 seconds. Or what you can say? Here across this inductor, I am calculating V1. So I will see across this V1 potential, what is the inductor? 3 Henry. And across this inductor, what is the equivalent resistance? 1 ohm only. That's it. So time constant is 3 seconds. Very easy. So this will be the final waveform with 3 second time constant and 1 impulse at t equals to 0. So very good question it was. So I hope you must have understood it. Okay. Thank you. Now let's see the solution of this problem. This is a very good question. So you need to talk about the power dissipated. You need to talk about power dissipated. So power dissipated simply means you need to talk about the voltage and the current. And power dissipated in what? You need to talk about power dissipated in the inductor. So I need to find the voltage and current in the inductor. So initially there is minus 2 ampere current. That means initially there is 2 ampere current that is flowing in this direction in inductor. I need to find ILT. I need to find the expression of ILT. Initially it is minus 2. At steady state it will be 2 ampere, right? At steady state it will be 2 ampere because this will be shorted. This is 4 by 2, 2 ampere. So steady state it is 2 ampere. Initially it is minus 2. So 2 minus 4 e to the power minus t by 2, where tau is L by R. That means 25 micro. So tau is L by R. This is your ILT. And what about your VLT? VLT. VLT. This I am saying this is my VLT. So at t equals to 0 plus, what is happening? This is 4 volt, right? At t equals to 0 plus, this is 4 volt. Just yeah. So we are writing the VLT expression. So this is your VST. At t equals to 0 plus, what is happening? This is your 4 volt and this current is flowing in this direction. 2 ampere current is flowing in this direction. That means this drop will be 4 volt, right? So at t equals to 0 plus, VL 0 plus is 8 volt. And steady state it is going to 0 only because this will be shorted. This will be 0 volt. So 8 into e to the power minus t by tau. So power dissipated would be I2 into VLT. Now tell me what this expression will be. The current is getting into the inductor. That means what we are finding? Power delivered to the inductor or power absorbed by inductor. Say yes or no. The current is getting into the positive terminal. The current is getting like this. That means what we are finding? Power delivered to the inductor, right? Power delivered to the inductor. delivered to inductor, right? Power delivered to inductor. So this is this expression that we are getting VLT into ILT. This is power delivered to the inductor e to the power minus t by 25. Okay, there everywhere ut is there. Basically, this ut is everywhere. So this we have found power delivered to the inductor. Now what they are saying, this is the expression that we are getting. Now based on this expression only everything will be running. This is power delivered to the inductor, that is 16 and 32. 16 e to the power minus t by 2 micro, and then sorry, this will be 8, we are just multiplying it, right? So 16 e to the power minus t by 2 micro, then 8 4 are 32, and this will become 2 here, right? Because this will be e to the power minus t by 25 micro, also this will also get multiplied. So e to the power minus 2t by 25 micro, 25 micro, 25 micro. All this is 25 micro, not 2 micro. 25 micro, because tau is L by R 25 micro. So all this is 25 micro. 25 micro. Minus 32 e to the power minus 2t by 25 micro. This is the scene, right? Yeah, this is the scene. Now what they are asking, power dissipated in the inductor is 0. So this is the power that is 0 when it is 0. So you need to put it equals to 0. So for first one I need to put it equals to 0. So what I will be getting, e to the power minus t by 25 micro, this is 16, that is, if I am equating it to 0, so I will put it equals to 32 e to the power minus 2t by 25 micro. So if I get the value of time t here, I will get 17.3 microsecond. Okay, I remember the answer. So this will be the answer, 17.3 microsecond. What they are asking you next? What they are asking you next? 17.3 microsecond. So this option is correct. The inductor is delivering power to the circuit for 17.3 microsecond, and the maximum power absorbed by the inductor is 2 watt. So this is the power delivered to the inductor, power delivered to the inductor, or power absorbed by the inductor. So we just need to draw the graph of this one. If I need to get the maximum power, what I need to do, I will differentiate it, right? I will differentiate it. If I need to get the maximum power, I will differentiate it and put it equals to 0, right? Very easy. Divided by 25 micro, minus sign, minus, and then another minus would come, so it would be plus e to the power minus 2t by 25 micro, and into 2 will also be there. This is the differentiation, and I will put it equals to 0, right? So 4 would come here, and this would be e to the power t by 25 micro is equals to 4. So t you are getting as 25 micro ln 4. So at this time where your power is maximum, power maximum time. So at this time your power is maximum. So what is your maximum power? So that would be 16 into, I just need to put this expression. So ln t, this will get cancelled, minus ln 4, minus 32 into 25 micro will get cancelled, power minus ln 16, and into the power is certainly there. ln 16 is certainly there. 1 by 4 minus 2. Answer is 2 watt. So this is correct. So maximum power delivered is 2 watt. Sorry, maximum power absorbed by the inductor is 2 watt. Is that so? Yeah, so it is 2 watt. Why it is 2 watt? Because what we are finding, power delivered to the inductor, or we can say power absorbed by the inductor. Because we are finding power delivered to the inductor, the current is getting in, so power absorbed by the inductor, that is 2 watt. So this is what we are getting. So this is the second. And third, what they are asking us, that inductor is delivering power to the circuit for this much of second. Is that so? Let's check that out. So what we need to do, we need to draw the waveform. What is happening? So what did we get to know at this time? Let's calculate this time. This would be 25 micro ln 4. 25 micro ln 4. 4 ln into 25. 4 ln into 25. 4 ln into 25. So 34.65 microsecond. Okay. So at this time 34.65 microsecond, 34.65 microsecond. This is my time t and this is pt. And what do you mean by pt? This is power absorbed by inductor or power delivered to the inductor. Power absorbed by inductor. Absorbed or by inductor, or you can say power delivered to the inductor. Power delivered to inductor. So this power delivered to the inductor is 2 volt here, right? This is 2 volt. And at 17 point something, 17.3, at 17.3 microsecond, it was 0. It was 0. One thing I certainly know, when I differentiated it, I am getting PT max equals to 2 watt. This value I am getting equals to 2 watt. What does that mean? That this will be the peak of the curve. This curve we are drawing, 16 into e to the power minus t by 25 micro minus 32 into e to the power minus 2t by 25 micro. This curve we are drawing. One thing I got to know that at this point we get a peak. Now peak can be coming from the upside like this, or it can come from downside as well. But we don't know how it will come, right? So can it come from the upside? If it comes from the upside, at 17.3 you have to go to 0 and then you will go like this. So here you are getting two peaks, this one peak here and one peak here. Are you getting this point? If it is coming from upward, so it will go like this and then like this. So one peak here and another peak here. This is what you are getting if you think it is coming from the upper side. This is simple mathematics. So it has to come from the downside. Say yes or no? It has to come from the downside. So after that, how it will behave, we don't know. Okay, it can go like this or anywhere it can go, but certainly this will be a peak and it has to come from the downside. So for this much of window, it is negative. The power is negative. So what they are saying, power delivered by the inductor is negative. Sorry, power absorbed by the inductor is negative. That means power delivered to the inductor is negative. What does that mean? The inductor is actually delivering power to the circuit. Say yes or no? The power delivered to the inductor is negative. That means power is not actually being delivered to the inductor. Inductor is actually delivering the power. So if it is negative, that means inductor is delivering power. Because we were finding power delivered to the inductor. Then we got to know it is negative. That means inductor is delivering the power. So inductor is delivering the power. So if inductor is delivering the power, that means for initial 17.3 microsecond, inductor is delivering the power, and the maximum power absorbed by the inductor is also 2 volt. So these three are correct. So this was a very good question. I hope you must have understood it and everything regarding this. What do you mean by power delivered, power inductor, power delivered, power absorbed, and every single thing must be clear. How to write the power expression, then how to draw the waveforms, right? Okay, then let's see this problem. So this problem is not tough, this is lengthy, that's it. If you know the concept, this will be very easy for you. If you know the concept, if you don't know, then it will be tough. So for that you need to watch a video where I have explained switch capacitors. Okay, so in that video, not in switch capacitor, it is there in some capacitive circuit only. Okay, in RC circuit only you will find this video. You can go to our YouTube channel, there you can find. So there you will find this RC circuits video. So from there you can prepare. So there are basically three circuits in this particular problem and you should know the working of all these three. So in brief I will tell you the approach, but I cannot give you the whole concept, right? In one video I cannot give the whole approach, but yeah, let's give you the approach. So the initial voltage across C1 is 3 volt, that is given. Across C1 it is 3 volt, and switches operation are also given, that for first 2 seconds S1 is on, then S2 is on, and then S3 is on. So these switches operation are also given. So this is the scene, that C1 and C2. C1 is having initially 3 volt. So initially only this switch is on for 0 to 2. This is the circuit for 0 to 2, because only this switch is on, these are off. So this much of circuit this much of circuit will not even come in action, right? So only this much of circuit is there. So let's find the potential across VC2. What that would be? Immediately potential will change, right? Why immediately? Because there will be infinity current, because there is no resistance, there will be infinite current, so immediately it will change. So VC2 at 2 seconds, what you will get? Actually at 0 plus only it will change. VC2 at 0 plus only it will change. It will be 3 into C1 upon C1 plus C2, right? So 3 into C1 is 1 farad upon C1 plus C2, it would be 3. So immediately it will come to 1 volt. So this will come to 1 volt immediately. So at 2 seconds as well it will be 2 volt, 1 volt only. Always it will remain at 1 volt. Now for 2 to 4 seconds what will happen? From 2 to 4. From 2 to 4. This is your C2. This is your C2 which is at 1 volt. The C2 is at 1 volt. This is resistance R. This circuit is gone because switch has been open, and here as well the switch is open, so this circuit also will not come in action. Now this is C3. Okay. So here initially we need to find the voltage across C3. Why voltage across C3? Because in the next part this switch is getting on. So C3 will come in action. So now we will find the potential across C3. So what will be the potential across C3? Initially it will be 0 volt only. Why it will be 0 volt? Add 2 plus. Why it will be 0 volt? Can you tell me? Because here if I say it is 0 volt, what will be the current? 1 by R. So there is no infinity current. If there is no infinity current, that means voltage will not change instantaneously. If voltage is not changing instantaneously, so it will remain at 0 volt only. At steady state, where it will try to go? At steady state, both of the potential will be equal. And how they will be equal? They will be divided as per the charge conservation. So it would be 1 into C2 upon C2 plus C3. Look, these kind of things you have to study, then only you will be able to understand. Otherwise, it would be very tough for you to understand this. So 1 into C2, 1 into C2, 1 into C2, C2 is 2. So 2 upon 2 plus 3, sorry 2 upon 2 plus 1. So it would be 2 by 3. So at steady state it would go to 2 by 3. But the switch is getting open after 2 seconds. It is getting open after 2 seconds. So we need to check what is happening after 2 seconds. So VC3T equation we will write from 0 to it is trying to go to 2 by 3. Right? 2 into 1 and 2 by 3 it is going. Yeah, so e to the power minus t by tau. What will be your tau? Tau will be R into C2 and C3 both are in series, because I told you how to check series. If I say there is I current flowing from it, so same I current is flowing from here. So both are in series. So R is 1. R is 1 and C2 and C3 are in series. C2 and C3 are in series. So it will be 2 by 3. So this would be 2 by 3. Right? So VC3T I am writing VC3T. It is going to 2 by 3 e to the power minus t by 2, and tau we are getting 2 by 3, so it would be 3 by 2. So VC3 at 4 seconds, what it would be? Actually we are starting from t equals to 2 seconds, so here I should write t minus 2, right? Here I should write t minus 2. So what it would be at 4 seconds? So at 4 seconds, for that we need to calculate. So we will see what we get. So 4, 2, 2, 3 plus minus e to the power into 2 by 3. It was going to 2 by 3. The time constant of 2 by 3. Yeah, sorry, I wrote this equation wrong. It is going towards 2 by 3. So how will the equation look like? 2 by 3 into 1 minus e to the power t by tau. So 2 t by tau. So this is how the equation will look like. So here it is wrong. Let's just check at 4 seconds now. So what we will get at 4 seconds? So 3 plus minus e to the power minus 1 plus minus into 2 by 3. So 0.63, 0.633 volt. Okay. So this is what we are getting, 0.633 volt. So for let's check for t greater than 4. So for t greater than 4, what is happening? This C3, this is already having 0.633, and then in parallel there is a resistance, and then there is another capacitor. So here there will be infinity current. Why there will be infinity current? Why so? Because this capacitor will be shorted, so complete circuit will be shorted, so there will be infinity current, so they have to change their voltage instantaneously. And how they will change? So VC4 is your Vc4 at 4 plus second, or you can say Vc4 is your output only. This is your output only. So at 4 plus second, what that would be? 0.633 into C3 upon C3 plus C4. So C3 and C4 are equal only, so divided by 2. So 0.316. So initially it is 0.316. At steady state, what it would be? Everything will be discharged across the register. You have to see the concept, then only you will be able to understand why it will be discharging through the register. What is actually happening? Immediately they are changing their voltage. Immediately both of them are changing their voltage. So now the same voltage 0.316 will be developed here. And now if there is 0.316, that means this will drive 0.316 by R current. So from where this current would have been coming? From this side and from this side. So this current is coming. Now if current is flowing out of the capacitor, because capacitors were charged in this direction, so current is flowing out of the capacitor, that means capacitors are getting discharged now. If capacitors are getting discharged, that means this potential is going low. If this potential is going low, slowly it will keep on going low, low. At steady state, what will happen? It will be 0 volt. And if it is 0 volt, that means V0 is 0 volt. Both of the capacitor will have 0 volt only. So at steady state, it will go to 0 volt. Are you getting this point? What did I do here? Initially changing voltage, then resistor is driving some current. If resistor is driving some current, that means capacitors are getting discharged. So slowly it will keep on discharging until V0 goes to 0 volt. So this is your V0T. More deeper explanation also I have given, but in the lecture videos here I cannot give. And if I am framing the test series, this question is also framed by me. There is no textbook, nowhere you can find this problem. This is absolutely framed by me. These waveforms only I have drawn. So you are not going to find anywhere these kind of questions. So if I am framing the test series, if I am giving the test series, then I will frame the problems on my own, no matter from where you have studied. But on PrepFusion, if I am framing the test series, it will be according to me, right? So yeah. So both are in series, and certainly in GATE you will see in next 2 to 3 years or next year only these kind of questions will come, and people will start solving with Laplace transform, and they will say paper is lengthy, all those kind of things. But you will see, this my sure guarantee, these kind of questions will come. The way they are changing the pattern of GATE, people are not realizing it right now, but certainly later on they will realize, no issue. So C3 and C4 are in parallel, so 2 into 1, so it would be C3 and C4 are in parallel only, so both will be added. So 2 farad into 1 ohm. This will be the equation. At 6 you need to find, at 6 second you need to find. So 6 I will put there. So 0.316 divided by E, 0.12 volt, 0.116 volt. So approximately we are getting 0.116 volt. So this is the answer. Okay, well and good. It was not an easy problem, it was a lengthy problem, but if you know the concept, then it will be all easy. So that's why I took this problem, so that at least you should know the concept of these three kind of circuit. Here there was no resistance involved, here the resistance was involved but in series, here the resistance was involved but in parallel. Well and good. And these kind of questions, these two circuits have been already asked in the GATE examination, and people have solved it with Laplace transform only. It is a first order circuit. Why we need to solve by Laplace transform? We know the equation. If you have the good intuition, you will be able to solve it directly. If you don't have the intuition, then you will solve with Laplace. So why should we solve it with Laplace? I have given the approach here now. So you don't need to solve with Laplace. Okay, then let's see the next. So let's see this answer. Many of the people would have clicked on this, I guess. Okay, but let's see what wrong you did here. What wrong you did? Look, you need to find V0. V0 is the same across L1 as well. So basically you can take both of them in parallel. So what will be your circuit? L1 and L2 are in parallel only. So this parallel combination would become L1 into L2 upon L1 plus L2, right? And this is your V0. This is your ground, and from here the current source is applied, which is 550. This is R. Now this 550 current is flowing here, right? 550 current is flowing through the inductor. So from the inductor the current is constant. Current is not varying. The current is constant through the inductor. So what will be the voltage? Voltage is L di by dt. L di by dt. Right? What is the value of L? L is L1 into L2 upon L1 plus L2. Di by dt would be 5 into delta t. So this people would have thought, and they would have clicked on this. That's it. This is not I1, I2, this is L1, L2. So they would have clicked on this. Wrong. Why so? Because what did I ask you? Voltage at t equals to 0 plus I am asking. At t equals to 0 plus. So initially here there is an impulse. This is an impulse. But at t equals to 0 plus, voltage will be 0 volt. Answer is this. Impulse exists at exist at t equals to 0, not at t equals to 0 plus. So this was the issue here. That was the trap, that it exists at t equals to 0 plus. So this will be 0 volt, not this one. Okay. So this is V naught T potential. If I ask you what is the V naught potential at t equals to 0, what will be your answer? V naught at t equals to 0 I am asking. What is your answer? L1 L2 upon L1 plus L2. Is that your answer? Wrong. V naught at t equals to 0 is infinity. This is not potential, this is area. 5 into L1 plus L2. This is what? This is area. This is not the magnitude. Remember the property of impulse function. We write down the area. If I am writing xt equals to a delta t. So what does this show? A. This is the area. And what will be the unit of this area? Unit of xt, let's just say unit of xt is x unit. And unit of time, which is second. So unit of this will be unit of x into second. So similarly, unit of this will be what? Unit of this will be what? Unit of this will be voltage into second. And voltage into second is the unit of flux. So this is flux. If someone is asking you what is the flux at t equals to 0, then you will say 5 L1 L2 upon L1 plus L2. If someone is asking you what is the voltage at t equals to 0, infinity. At t equals to 0 plus what is the voltage? 0 volt. Okay, infinity, impulse, infinity. Magnitude is infinity. So at t equals to 0 plus there is high amount of voltage across the inductor. Well and good. Okay then, yeah. So let's see the solution of this problem. In this problem you have to find the expression of V naught t. Okay. So we can solve this by Laplace transform, right? We will solve it by Laplace transform only, because this is not a first order circuit. Why it is not first order? You will say, sir, only one storing element is there, so it is first order. No, it is not first order, because your input itself will give you a pole. What is your input? This is your input, 3 into e to the power minus t by 2. So it would be 3 upon s plus a. So your input itself is giving you a pole, and one more pole will come from here. So it is a second order circuit, not first order circuit. Okay. Only by seeing that there is one storing element doesn't mean it is first order circuit. There are actually two storing element. One storing element is there in this voltage source only, which we cannot see, right? So for that we have to apply Laplace transform. So you can apply Laplace transform, it will be calculation based, so you can do it. But what if in the examination only V1 value was asked? If only V1 was asked, then what you would have done? What you would have done? You would have put t equals to 0 in this expression. This is the expression of V naught, right? If I put t equals to 0 there, what I will get? T equals to 0, I will get V1 only. So at t equals to 0, what is the value of V naught? At t equals to 0. At t equals to 0, what is the value of input? 3 volt. At t equals to 0, if you put t equals to 0 here, what is the value of input? 3 volt. And minus 1 is the voltage across the capacitor, so 1 volt would have been the voltage here. So 3 plus 1, 4 volt. So at t equals to 0, V1 value is 4 volt, that's for sure. V1 value is 4 volt, that's for sure. So this option is correct. Now you can apply Laplace transform. So I am not going to do the calculation. Okay, calculation is complex, but you can do it on your own. Apply Laplace. Okay. So now you can apply the Laplace transform. What you will get as V naught t? V naught t. We will get as 4 minus 3t by tau. Tau will be 2 micro only. Tau will be this only. Okay. Why it is 2 micro only? Because from here as well, what is the time constant we are getting? RC, that is 2 micro. And in the input as well, we have time constant 2 micro only. So eventually we will get, this is not, we cannot say this is time constant. We cannot say this is time constant, okay? Because time constant means the speed of the circuit. But this V naught is never going to be stabilized. At t equals to infinity, it will just keep on going. So we cannot say this is a time constant, but tau value will be. From here as well, one tau we will get, that would also be 2 micro, and from here as well we are getting 1 tau, that is also 2 micro. So both of the poles will be at the same location, 2 micro and 2 micro. That means pole will be at same location. If poles are at same location, what does that mean? That it would be a critical damped system. If it is a critical damped system, then response will be C1 plus C2t into e to the power minus t by tau, or you can say whatever it would be. So it is like the same expression only, C1 plus C2t e to the power minus t by 2. So even if they had asked the expression, then you could have gone by that this would give you a time constant of 2 micro, and from here as well you are getting a time constant of 2 micro. That means both poles will be same. So expression will be in this manner. So what if they had asked the final expression? then you in the options you would see that okay, C1 plus C2 into e to the power minus t by tau, where it is. Okay, and tau will be 2 micro, so this option will be incorrect. So now this race is between V2 only. So for V2 there is no shortcut. I don't think there is any shortcut for V2. You have to apply Laplace transform, then you will get to know that it is minus 3. Okay, for V2 there is no shortcut at all. I tried thinking of it, but there is no shortcut. So V2 value we will get by Laplace transform. So when you do the Laplace transform, this will be your final expression. This will be minus 3 and then exponential e to the power minus t by tau. Tau is 3 micro. Sorry, tau is 2 micro. Sorry. So this will be your final expression. Two options I could have directly clicked, that this would not be answered 2 microsecond, it would be, now the race will be between V2 only. But in the examination, they will frame the question in a manner that you don't have to apply Laplace transform. That's why I am dealing this problem here. Laplace transform you can do, but whatever that can be asked in the examination from this particular problem, that I have told here. Okay then, thank you. So let's solve this question. You need to find V naught at 1 second. Okay, the switch was closed at t equals to 0. Okay then, so what you will do? V naught, first you will find transfer function. What is the transfer function? Transfer function is 1 upon cs upon 1 upon cs plus r, 1 upon rcs plus 1, 1 upon rcs plus 1. This is your transfer function. 1 upon, what is the value of rc? That is 1 only, 1 upon s plus 1. So what will be your V naught? V naught t. So what is the input frequency? That is 1 as well. Input frequency is also 1. So t of j omega first we will find, that would be 1 upon j omega plus 1, and input frequency is 1 as well, 1 radian per sec. So this would also be j plus 1. So magnitude is root 2 and magnitude is 1 by root 2 and angle is minus 45 degree. So this will be your V naught t, 1 by root 2 into, what was your input? Input was 5 sine t minus 45 degree. Is that correct? No, this is not correct. This is the steady state. This is steady state. This is only steady state. I told you one thing, right? Because you only, by this thing, by whatever that we are doing here, by this thing you get steady state value, not the transient one. Transient one also needs to be added. So this is steady state, STADAY, whatever it is, steady state. So this you are getting at steady state. What is the transient? So based on this, at t equals to 0, at t equals to 0, at t equals to 0, actually what should be your V naught at t equals to 0 or 0 plus? What should be your V naught? It should be 0 volt. At t equals to 0 plus, your V naught should be 0 volt. V naught plus should be 0 volt. Do you agree to this point? At t equals to 0 plus, it should be 0 volt. But actually what you are getting here, V naught steady state. If I say V naught at 0, V naught at 0 plus, based on the steady state expression, what you are getting? That you are getting as minus 5 by 2. Right? If you put 0 here, so it would be minus 1 by root 2, minus 5 by 2, minus 2.5. Look, if you have studied transient analysis in a good manner, then you know this kind of concept. If you haven't studied, then you would only know this is steady state. That's it. You would never know what is actually happening in the circuit if you haven't studied deeply. I know this might sound offending to you, but this is the reality. You can go and on YouTube only these videos are available. You can go and check out the video of AC transient. Okay, AC transient I have explained in network analysis, or you can say this is sinusoid response only, at steady state sinusoid response only. But actually this is the steady state value. We need to see the transient as well. So actually at t equals to 0 plus you are getting, you should have 0 volt, but you are getting minus 2.5 volt based on this expression. Based on this expression, then what would be the actual expression? So this was the steady state which we were getting. So based on this, at t equals to 0 into 5 as well. So based on this at t equals to 0 we are getting minus 2.5, but actually it should be 0. So this is giving you minus 2.5. So at t equals to 0 plus you should have another 2.5, and this is transient part only, so at steady state it will die, e to the power minus t by rc. So this I have explained already in our paid in our YouTube course only, that is freely available to everyone. So you can go and check out. This is how, this is the final expression. This is the final expression. Okay, this is not the final expression. This is only at the steady state. We got to know that at t equals to 0 we are getting minus 2.5, but actually we should get 0. So what we need to do? We need to add 2.5 so that at t equals to 0 we should get 0 voltage. At t equals to 0 we will get 0 volt here. We should add more 2.5. Okay, so we are adding 2.5 here. Well and good. Now what they are asking, V naught value at t equals to 1 second. V naught value at t equals to 1 second. So V naught value at t equals to 1 second. So 1 sec. So 5 by root 2 sine. Here if I am writing 1 second, that means I am writing in radian. So this also I will write in radian. So that would be pi by 4 plus 2.5 e to the power minus 1. So let's do the calculation. 1 minus pi by 4. So in your virtual calculator that will be available in your gate examination, so you will put 1 minus pi by 4 and you will do the radian as well, because by default it will be on degree. So if you have the calculator, you can see that it will be put on radian now. So pi by 4, and then you need to take sine, you need to take sine, and then into 5 by root 2. So 0.752 you are getting here. So if you have clicked on 0.752, it would be wrong. Plus this also would come. So 2.5 by E, 2.5 by E, 0.91 or 92 plus 0.752. So 1.67 we are getting, 1.67 volt. So this is the final answer. Okay. So you should have a better concept, then you will be able to solve it. Okay then. So let's see this question. You need to find all these values in this problem. Basically you need to find 6 values: V0 plus I0 plus dV naught by dt at t equals to 0 plus di by dt at t equals to 0 plus and at infinity. Okay, so this is the circuit. So this voltage is there, this particular voltage is there for t less than 0, and this is coming for t greater than 0. So for t less than 0 this was there, this was not there. So steady state would have been reached already, right? Steady state would have been reached. So at t equals to 0 plus, steady state would have been reached. So for t less than 0, what would have happened? Or I can say at t equals to 0 minus, what would have happened? This would be open circuited and this would be shorted, right? This would be shorted. So what would be the current? 1 by 2 ampere. 1 by 2 ampere would have been the current. 1 by 2 ampere would have been the current. So this would give you a drop of, basically this would be shorted, this would be open circuited. So current would flow in this manner. This is not even there because this is coming for t greater than 0. So current would flow in this manner, half ampere, and a half ampere into 5, 2.5 volt. So your VC 0 minus, that is 2.5 volt, and that would be equals to VC 0 plus. And what about your current? Current IL 0 minus, that would be equals to your IL 0 plus only, and that would be equals to half 0.5 milliampere. So 2.5 plus, what is the answer of first one? 2.5 plus 0.5, 2.5 volt plus 0.5 ampere, 3. So answer of first one is 3. Very easy problem. First one is very easy. So basically what did we get to know? That this is driving half ampere current at 0 plus. So everything is asked at 0 plus only, so we can write down at 0 plus only. So this is driving half ampere current and this is having a drop of 2.5 voltage. I can write 2.5 voltage. This is having a drop of 2.5 voltage. Better I should write here. Okay. Now what you need to find? dV naught by, what you need to find? dV naught by dt. dV, V, this you need to find, dV by dt. How we can get the differentiation of voltage, differentiation of capacitor voltage, how we can get from the capacitor current? So IC 0 plus would have been C dV naught by dt, right, at 0 plus. So what we need to find? We need to find the current at 0 plus in the capacitor divided by the capacitance value. That would be our answer. Now we need to find the current at t equals to 0 plus. What would be the current in the capacitor? So if 2.5 is here, then certainly this current would have been half. Sorry, 2.5 by 5. It would be half only. 2.5 by 5, right? 0.5 ampere current would have been here. So this current would have been what? 4 minus 0.5, 3.5. Say yes or no? 3.5 ampere. Are you getting this point? At t equals to 0 plus, my target is to find the current in the capacitor. So this voltage is 2.5. So same voltage is there across this resistor as well. So it is driving 0.5 ampere. This is driving 3.5. So this would be driving 4 ampere current, right? So the current is 4 ampere and capacitance value is 1 farad. So what is our answer? 4, right? 4 ampere. Ampere, whatever it is, it would be simply volt per second. So 4 is our answer. So this is the value of P. P value we have got 4. Are you getting this point? This current is 4 ampere. This was half, this is 3.5, so this is 4 ampere current. So this value we have got. Now what we need to find? di by dt. What is I? I is the current through the inductor. So how do we get the differentiation of current? How do we get the differentiation of current? VL is equals to L di by dt, right? VL is equals to L di by dt. So if I need to find the value of L di by dt at t equals to 0 plus, so I just need to find the voltage across the inductor. That's it. This is my target. I need to find voltage across the inductor. How can I find voltage across the inductor? I know this voltage. I already know this voltage. What is that? This voltage is 2.5. Say yes or no? And voltage in this direction, because current would be flowing from the positive to negative inside. Voltage in this direction. If this is my inductor and this is my current I, then what will be the voltage? V. V is equals to L di by dt. If I take the current in opposite direction, then negative sign will come. That means if the current is getting into the negative, then negative sign will come. Okay. So this much basic you should know, I guess. So this is 2.5 volt. And this 4 ut is gone. At t equals to 0 plus, this is gone. This is shorted at t equals to 0 plus. And we know the current here as well. This is 0.5 ampere. So what will be the drop in this direction? 1.5 volt. So here you are having minus 1.5 and here you are having 2.5. Minus 1.5 and 2.5. That means in this direction you are having 4 volt. Say yes or no? This was 2.5 volt. At t equals to 0 plus, capacitor will hold its voltage. At t equals to 0 plus, it will hold its voltage. So this will be 2.5 and this is gone and this current is 0.5 ampere. So 0.5 into 3. In what direction? Across the resistance. In what direction? In this direction. 0.5 into 3. 1.5. Right? So 0 and minus. Here you will get minus 1.5 and here you are getting 2.5. So in this direction you are having 4 volt. Right? So it would be minus 4 by L. L value is half. L value is 1 by 4. L value is 1 by 4. 0.25, no? Yeah. So minus 16 you are getting. Q value you are getting is minus 16. What they are asking? P plus Q. So what is your answer? Minus 12. Right? Well and good. Now in the last you need to find at infinity. So at infinity what will happen? This will be open circuited and this will be shorted. And 4 ampere is there in the action. 4 ampere is there in the action. This is open circuited and this is shorted. So what will be the current? Current in 3 ohm. Current in 3 ohm. Current in 3 ohm. What will be the current in 3 ohm? I at infinity. This is already shorted. This is open circuited. So current will be divided 5 by 8. Current will be divided 5 by 8 into 5 by 8 into 4. 2.5 but negative sign will come. Because current will be flowing in this direction, I is taken in this direction. So negative sign will come. So minus 2.5 ampere. And what about V of infinity? So you are having 2.5. So 5 kilo ohm will have 1.5. 1.5 into 5. 1.5 into 5. That would be 15 7.5. So what will be the addition? Addition will be 5 only. Right? So that's it. These are the answers. Okay. So for this question, this is directly from our class notes. A bit lengthy it is. So you can go, here I have written, you can go to network analysis playlist on YouTube. Lecture 45 you need to see. The title of the lecture is Sinusoid Steady State Response, something like that. And it will start from 55 minutes 55 seconds. So you will exactly see this question there. And you will also get to understand a lot of new concepts as well, which you might not have studied. So here basically what is happening, first switch A is there for a very long time. So this would have, so here basically 1 by 2 ampere current would have been set up. And now you need to find the time T0 at which you should keep it to B so that there is no transient response. Okay. So that you will understand. You can watch the video directly there. You will understand the complete solution. Okay. There is needlessly, I will waste my time here by making the solution. Please don't get frustrated over it. that you have to go to the YouTube channel and watch it. Just you need to go there and just watch the solution. It will be all clear to you. Okay, yeah. So let's see this question. You have to find the voltage V naught from figure B. So what did I tell you? How do we solve these kind of methods, these kind of problems? What we need to find first, we will see voltage V naught. So here I will find VTH and RTH, or I will try to replace this box as VTH and RTH, because this 4 ohm I already know. So this is what I will try. And how will I find VTH and RTH? With the help of this one. This is my first approach. This is my first approach, that first I will try to find VTH and RTH. Let's see if I am able to find it or not. So how will I find? With the help of this one. So what I will do, I need to find VTH. So what I can do, I can make open circuit voltage here. Open circuit voltage. What is VTH? VTH is open circuit voltage. So basically this is how my equivalent circuit would look like if I want to find VTH. So this is open circuit, and this 5 volt will remain there as it is. This is your AA dash. Don't forget the nodes. Never forget the nodes. This is BB dash. Okay. So if 5 volt is here, then how much voltage I will get here? This is what I need to find. So across AA dash, if 35 volt was there, then you got 20. If 35 was there, you got 20. If 1 was there, you would have got 20 by 35. And if 5 is there, you would have got 20 by 35 into 5. That means 20 by 7 volt. So your VTH is 20 by 7 volt. VTH is 20 by 7 volt. You can find VTH, RTH, or you can find Norton as well, because two of the things you require. If you have these two, then you can find this. If you have these two, then you can find this. If you have these two, then you can find this as well. So VTH I am able to find. Now my target is either find Norton current or you find Thevenin resistance. Can I find any of these? VTH I have got to know 20 by 7. Now this is not the answer, because this is threshold voltage. Sorry, not threshold voltage. This is Thevenin voltage, not your voltage V naught. This is Thevenin voltage considering open circuit. So 20 by 7, this is certainly not the answer. Now what is my target? My target is to find Thevenin resistance and Norton current. This is the short method of proceeding in a problem. So let's try to find Thevenin resistance. So what I would do for finding Thevenin resistance, I will apply VDC here and get IDC out of it, right? And I will short circuit this. Do you see any kind of circuit here like that? I need to find this value. I need to find something like this. I need to find this circuit with the help of this circuit. No, nowhere we can get a short circuit path. Can I get a short circuit path? I need to short it. I need to short my 5 volt source. So at least I need a short circuit path. Do I see any short circuit path here? No. In the whole circuit, I do not see any short circuit path. So I cannot find RTH. Can't find RTH. And neither I can find ISC. Why I cannot find ISC? Because for finding ISC, what I need to do? I have to short circuit the load. And in the load, I need to find the current. Right? ISC or IN, you can say, Norton current. So in the short circuit, I need to find the current. This is my target. This is how I find Norton current, right? And 5 volt will remain there as it is. Can I make any circuit like this? For this as well, I need a short circuit path. Do I have any short circuit path here? No. So first I went with the conventional approach, that find VTH, RTH or IN. Two of the things you need to find. Then I got to know that I can find VTH, but I cannot find RTH and I Norton. So what is the other way? Hit and trial. You need to think of this circuit. If you go with this approach and you are not able to find two of the parameters, then you need to think of the circuit. With the help of this given data, I will think of the circuit now. What could be my circuit? So this is the short approach of going with the problems like this, with the block diagram problems. If two are given, first get to know that what you need to find. I need to find the voltage here, so I would at least need VTH, RTH or IN. Then I got to know that I can find VTH, but I cannot find RTH or IN. Then what I need to do? Now I need to think of the circuit only. So think of the circuit now. So what do you think? How you will think? You know the voltage here, you know the current here. That means certainly from here equivalent resistance would have been 7 ohm. Say yes or no? Because 35 by 5, 7 ohm. Right? Voltage by current. Certainly from this node, from AA side, you would be seeing 7 ohm resistance, total 7 ohm resistance, and this is giving you 20 volt drop and current is 5 ampere, then certainly here there would have been 4 ohm resistance, right? And this would have been 3 ohm. Look, 5 ampere, 3 ohm, 4 ohm. So total voltage drop would have been 35 and 5 ampere into 4, 20 volt drop here. That's it. So this would have been your network. This is how your network would look like. So I will make it on the next page again. So your network would look something like this. Three ohm and 4 ohm, right? This node is AA dash, AA dash, and this side is BB dash. From here 5 ampere current is coming. 5 ampere current is coming. So total voltage drop will be 5 ampere from here, 5 ampere from here, 35, and across this it would be 20 volt, right? So this is what we are getting, 20 volt. Okay. So now what do I need to find? I need to replace this circuit here. So across AA dash there is 5 volt. Across AA dash there is 5 volt. Never forget the port. The port is AA dash. So it's not that I am going to apply 5 volt here. No. 5 volt is applied across AA dash. So this is your 5 volt. Now across BB dash there is 4 ohm, and across that only we need to calculate the final V naught. So what will be the current? For 2 current would be 1 ampere. Basically this current would be 1 ampere only. So this voltage drop would be 2 volt. This V naught will be 2 volt. Okay. V naught will be 2 volt. Okay. Very simple. 4 and 4 parallel, 2, 2, 3, 5, 1 ampere current is there. So 1 into 2, 2 volt. Okay. So this was a good problem. You need to think what you need to actually find. Okay. Let's see the solution of this one. What you need to find? You need to find passive networks. So passive, those who absorb the energy. Okay. They do not deliver the energy. They don't have the capability of delivering the energy. And for them, impedance is always positive. Impedance is always positive for passive. And for active, it can be positive as well or negative as well. What is the example of active? BJT, MOSFET, and op-amp that we study in analog electronics, right? This is active. So Z should be always positive. Here V and I both are positive, so it would be positive only. And here V and I both are negative, that means it would be positive, because Z is V by I. So V and I both positive, that means Z will be positive, and V and I both negative, that means also Z will be positive. Here Z will be negative in this side, so this is not the correct answer. In this one as well, Z will always be positive, because here also it will be positive, here also it will be positive. So always in first and third quadrant it can be. If your waveform is going into second or fourth quadrant, that means it cannot be passive. So this is your active, this is also active. Okay, so these two cannot be there because they are going into second quadrant, and this is going into fourth quadrant. Okay, so answer is first and third. Well, so let's see the solution of this problem now. So there are 4 problems in this one. First one is this: the switch is open, then at what time steady state will be reached? Then steady state is reached, so at that time what is the voltage across the capacitor? Then switch S is closed, then when will the steady state reach? And if steady state has been reached, then what is the voltage across the capacitor? So 2 circuits are there and 4 questions are there. So firstly, the switch S is on. So if switch S is open, then how will your circuit look like? This is how your circuit will look like. This is 5 volt, right? So now what will happen, as we have already seen this example in our class notes only. So what will happen? There is high chances that this diode will turn on, because this 5 volt will deliver the current in this direction. And if it is delivering the current in this direction, that means the current is flowing from P to N in the diode. So diode will turn on. So if diode is turning on, then diode can be replaced with a simple battery. So if diode is replaced with the battery, then it will be replaced something like this with the cut-in voltage of 1 volt. It is given that the cut-in voltage of diode is 1 volt. So that is 1 volt. This is capacitor C, which was having 5 volt, and it is replaced with 1 volt. So now what is the voltage that is coming across the inductor? That is 4 volt, right? 5 minus 1. 4 volt is coming. So in which direction the current would flow? The current would flow in this direction. ILT. So I can write down the ILT equation. What that ILT equation would be. So there are two sources, 5 volt and 1 volt. Now what is the total voltage across the inductor? What is the initial current across the inductor? What is the initial current? I told you how to write it intuitively. What is the initial current? 0. At steady state, what will be the current? At steady state, inductor will be shorted and capacitor will be open circuited. If capacitor is open circuited, both are connected in series, so certainly it will also be 0. At steady state also it is 0, initially also it is 0. That means what will be the response? Response will be sinusoid. And how do you find the response? Response will be sinusoid. So some magnitude into sinusoid. What will be that magnitude? Voltage by resistance. Voltage into root C by L. So this is the intuitive method. This is how we write down the current equation. If you don't know, you can watch the lecture. Then only you will be able to understand how did I write it from here. Initially 0. At steady state also it is 0. That means this will be the current equation. It will follow sinusoid rule. So it will be 4 into root C by L sin omega t. If you keep on applying Laplace transform, it will be very tough. That's why we have developed this method. So 1 by root LC, 1 by root LC. So, and root C by L would be 1 only. So 4 sin t by 2. This is the expression we are getting. This is your ILT. Now tell me, when will the steady state reach? The switch S is open. So current is flowing in this manner. But the current is sinusoid. After some time, it will change its direction. If the current tries to change its direction, then what will happen? Diode will be off. Say yes or no? If the current tries to change its direction, then diode will be off. Because what is the waveform of current? Let this question be here, but we have to proceed. What is the waveform of the current? Waveform of the current is something like this. Right? This is your ILT. From 0 to 4 it was going. ILT was 4 sin t by 2. 4 sin t by 2. So when it will be 0? When it will be 0? At what time it will be 0? When t by 2 is equals to pi. When t by 2 is equals to pi, at that time it will be 0. So this time should be 2 pi. So after that what will happen? The current will try to go to negative. If it is trying to go to negative, at that time only the diode will be turning off. At t equals to 2 pi plus, what will happen? The current tries to go to negative. That means diode will be off. Diode will be off. And if diode is off, that means there is no current flow now. If diode is off, then inductor is different and capacitor is different. There is no connection between inductor and capacitor. Both are different. So this is how your circuit will look like. There is no connection. So this is the steady state. Say yes or no. Here the current is 0 ampere. Current will be 0 ampere now, because here the current was 0 ampere. It tries to change the direction, but it is gone now. Now we don't know what is the voltage across the capacitor at t equals to 2 pi. But when will be the steady state reach? This is the time when steady state reach. Steady state reached. Steady state. So that means steady state reaches at 2 pi second. This we got to know. So this is our one of the answer, that it reaches at 2 pi second. At that time, what is the voltage across the capacitor? So for that we need to find out the expression of VCT. This was our VCT. So we need to find out the expression of VCT. So how many sources are there? 5 volt is there, 1 volt is there. So this was the scene. This is our capacitor and VCT we are writing. So VCT expression we are writing. So initial voltage was 5 volt. So because of 5 volt, initial voltage is 5 volt. What we need to do? We need to apply superposition theorem. So 1 volt we are not going to consider. There was no initial current in the inductor as well. So initial voltage was 5 volts. And at steady state it will be 0 if I am applying superposition. That means I am not considering this 1 volt source. If I am not considering this 1 volt source, that means because of this 5 volt, only because of this 5 volt, initially we will have 5 volt across the capacitor, and at steady state it will be 0. Why it will be 0? Because this is shorted. 1 volt is shorted and there was no initial condition here. So basically complete circuit will be shorted only. So there would be no voltage. So because of this we will write 4 cos omega naught t. Now I will only consider this 1 volt source. If there is this 1 volt source, and I will not consider this 5 volt source. So at t equals to 0 you are having 0 voltage, but at steady state what voltage you will have? This will be shorted, this will be open circuited. So if this was 0, this was ground, then this is 0, 0, 0, this would be 1 volt. Right? At steady state this would be 1 volt. If I am considering only 1 volt source. I hope you are understanding. I am applying Here I am applying the superposition theorem. I cannot give you the concept right from the scratch. For that you can watch my comprehensive lectures that is available on YouTube only. So this inductor will be shorted at steady state. This will be open circuited. So that would be 1 volt. So what I will write, 5 cos omega naught t plus 1 and then bracket 1 minus cos omega naught t. So this will be my final expression. That would be 1 plus 4 cos omega naught t. And omega naught is 1 by 2 that we know. So this would be my final VCT expression. Say yes or no. Understood? And you can check here as well. At t equals to 0, what is the voltage you are having? 5 volt. Right? You can check from here as well. So this is your VCT. So as the time of steady state, what was the time of steady state? That was 2 pi. So at the time of steady state, what would be the voltage here? That would be 1 minus, put t equals to 2 pi here. So it would become pi, and cos pi is minus 1. So 1 minus 4. That means minus 3 volt. So at this time you would be having minus 3 volt here. Say yes or no. You would be having minus 3 volt here. Or you can say I was having 3 volt in this direction. So this capacitor got discharged. From 5 volt to it got discharged to minus 3. From 5 to it has went to minus 3 volt. So this has happened with the capacitor. After that there was no further discharging because the diode went off. So find the steady state voltage across the capacitor. That would be minus 3 volt. So this is a very very famous question that has been asked in the GATE examination for 3 to 4 times. Okay. But they never connected 2 diodes. So I am really hoping that they will connect 2 diodes now. So if they connect 2 diodes, it will be very very interesting. So now we will check out what will happen if they connected 2 diodes. Because switch S is closed now, that means 2 diodes are connected. And their polarities are opposite. First one is towards this direction and the second one is towards this direction. Question is same, initial condition is same, everything is pretty same. This is L, this is C. This is having 5 volt, right? This was your diode D1, this was your diode D2. So initially what will happen, this is 5 volt. So capacitor will discharge in this direction. So which diode will turn on? D1 will turn on. Initially D1 turns on, right? And D2 is off. Why D2 is off? Because one of them will turn on, no? Because if current is flowing in this direction, that means D1 turns off, then D2 will be off. So D1 turns on. So what will be your circuit? Exactly the same which we have already solved. The same manner. This will be your circuit, right? This is 1 volt. This capacitor C was initially having 5 volt. Right? So can I draw the waveforms? IL waveform I know. Right? I know the IL waveform. It will go till 2 pi. This is 4. This was your ILT. ILT I am taking in this direction. And VCT is this direction. And what about VCT? Because this analysis we have already done. This analysis we have already done. So VCT have went from 5 volt to minus 3 volt. 5 volt to, it has went from 5 to minus 3. 5 to minus 3 volt. Okay. This is your VCT. Now in the previous problem what was happening? Here the current was going negative, right? Current was going negative. Just as the current tries to go negative, in the previous problem the diode was turning off. But here if the current tries to go negative, then what will happen? D2 turns on. Say yes or no. After at t equals to 2 pi plus, what will happen? The current tries to go negative, that means D2 turns on. So at t equals to t by 2 plus, D2 turns on. D2 turns on. So now we will check at t equals to 2 pi plus what is happening. D2 turns on. So if D2 turns on, it will be replaced with this 1 volt battery here. Okay. And the capacitor was charged for 3 volt, right? Capacitor was charged for 3 volt. Minus 3, that means in this direction it was charged for 3 volt. Now in which direction current would flow? In this direction only. So yes or no? In this direction, because 3 volt will give the charge in this direction. And what is the current in the inductor? It is 0 ampere only. Here you get to know that here you left the inductor with 0 ampere current. So inductor is driving 0 ampere current only. But now the current can flow in the opposite direction. Current can flow in this direction. Current will flow in this direction and it will charge the capacitor now. Okay, so current will flow in this direction, but we have taken IL in this direction only. This is the direction of ILT. So what will be the voltage across the inductor now? If this was 0, then this would have been minus 3, this would have been minus 2. 0, minus 3 plus 1, minus 2. That means in this direction it is having 2 volt. So better I should remove this current one. So in this direction it is having 2 volt and in this direction the current is flowing. Current is flowing in this direction. So can I write down the ILT expression? What will be my ILT expression? ILT expression, that would be minus 2 sine omega naught t. Omega naught is same only. So minus 2 sine t by 2. Say yes or no? Right? But we are starting from 2 pi, so better I should write t minus 2 pi by 2. Did you understand what did I do here? I am not starting from t equals to 0. I am starting from t equals to 2 pi. This expression I am getting after t equals to 2 pi. So whatever that is 0, that would be our 2 pi. If I put t equals to 2 pi here, it would be 0. If I put t equals to 3 pi here, that means it would be pi. So instead of t, I have put t minus 2 pi. This we do a lot of time in transient. The switch turns on at t equals to 1 second. Then what we will write? E to the power minus t minus 1 by 2. Because we are starting from t equals to 1. So here we are starting from t equals to 2 pi. This is happening at t equals to 2 pi. So here I can write t minus 2 pi by 2. Right? So this is the current equation. So if I draw the current waveform. So initially it was going in this manner. 0 to 4 for 2 pi time. Now when it will become 0 again, now it will follow in the negative direction. This was 4, right? This is your ILT. When it will go in the, now it is going into the negative direction, when it will go to 0 again with the magnitude of 2. Magnitude of 2. So when it will go to 0 again, when this particular value is t minus 2 pi by 2 is equals to pi. That means t is equals to 4 pi. So here at 4 pi this will go to 0 again. After that it will try to go to positive, right? So at that time this current will be 0. After that at t equals to 4 pi plus, what will happen? The inductor current will try to be positive. And if it tries to be positive, if the current tries to be positive, that means current is flowing in this direction. What does that mean? That means this diode will turn on. Initially what was happening? The current was flowing in this direction. So diode D1 was turning on. Then suddenly the current tries to change its polarity. So it started flowing in left to right. If it is flowing from left to right, then D2 turns on. Now if D2 turns on, then this is the waveform of current. So now after 2 pi time, that means at t equals to 4 pi plus, again current is saying that I will flow in this direction. So again it will turn on diode D1. So we will turn on diode D1 now, but before that we need to write the capacitor waveform as well. Because what is the capacitor voltage, that we don't know. So let's write down the capacitor voltage. So because of minus 3 volt only, what it would be? Minus 3 cos omega naught t. Right? And because of this 1 volt, because of this minus 1 volt, initially there was 0, and because of this minus 1 volt, at steady state it will have minus 1 volt. So minus 1 bracket 1 minus cos omega naught t. So this is what we will get. So it would be minus 3 plus 1 minus 2 cos omega naught t minus 1. So this will be the expression we will get. Minus 2 cos omega naught t minus 1. But again one error I did here. Again I need to put t minus 2 pi. Okay. So what would be the actual equation? Minus 2 cos omega naught is 1 by 2. So t minus 2 pi by 2 minus 1. Instead of t, I need to put t minus 2 pi, right? Because we are starting from t 2 pi plus. So t minus 2 pi I need to write. So at t equals to 4 pi, what we are getting? VCT value at t equals to 4 pi. What we will get? At t equals to 4 pi, it would be pi. At t equals to 4 pi, if we put 4 pi here, 4 pi minus 2 pi would be 2 pi. 2 pi by 2 would be pi. So cos pi is minus 1. So 2 minus 1, 1 volt. So at t equals to 4 pi, you are having 1 volt. Okay. So I need to add another page. So what is our waveform of capacitor? So what was our waveform of capacitor? From it started from 5, then in 2 pi time it went to minus 3, then in another 2 pi time it from minus 3 to plus 1. From minus 3 to plus 1 at 4 pi. Now let's check what happens. Now again we have to check what will happen in the circuit. So now D1 has turned on. So this is your inductor. Again, what is the inductor current? At t equals to 4 pi plus. I am drawing the circuit at t equals to 4 pi plus. What is the inductor current? It is 0 only. Which diode has turned on? This diode D1 has turned on. This diode D1 has turned on. This is 1 volt. Now this is the capacitor C. This is the capacitor C, which is having 1 volt in this direction. This is C, this is L. It is having 1 volt in this direction, right? So this is having 1 volt. Now what will happen? Now let's try writing the ILT equation. So what will be your ILT now? This is 1. What is the voltage across the inductor? 1 minus 1, 0 volt. What is the voltage across the inductor? That is 0 volt. So what will be your ILT? 0 into something. So that would be 0 ampere only. So now in this condition, after this condition, the steady state has reached. Okay. The steady state has reached. So this is the steady state potential only. So this is the steady state condition. At t equals to 4 pi, steady state has reached. So this is the steady state condition. Okay. So here the steady state has reached. So this would be your final capacitor waveform, VCT. So it would be 1 volt. And here this will drive 0 ampere current. After that, it would be driving 0 ampere current. Always it would be driving 0 ampere current. So what is the steady state voltage across the capacitor? VC steady state. It would be always 4 volt. And when did we reach the steady state? At t equals to 4 pi. When did we reach the steady state? At t equals to 4 pi. So did you understand the difference between both of the problems? In the first one, there was only the diode, one diode. So it wasn't allowing the current to flow in the opposite direction. But in the next problem, there was 2 diode. So it would allow the current to flow in the opposite direction. But if the voltage across the inductor is becoming 0, if the voltage across the inductor is becoming 0, that means there will be no current. If there is no current, that means that is the steady state. There will be no charging, no discharging. If there is no current flowing, that is the steady state, right? No further charging, no further discharging. You can write down the VCT equation as well. What you will get as VCT equation? So because of 1 volt, you will write 1 cos omega naught t. And because of this 1 volt, what you will write? 1 plus 1 minus cos omega naught t. Because at steady state, you will have 1 only. So what you will get? 1 volt only. So VCT is also fixed. That is 1 volt. Or from here also you can see if the current that is flowing from the capacitor is 0, that means capacitor will not discharge. So that is fixed at 1 volt. So this is the steady state. So what is the steady state voltage across the capacitor? That is 1 volt. And the steady state is reached at 4 pi. So these kind of questions may come up in your examination. Okay. So yeah, I hope you must have understood it and it was a very, very good problem. Thank you. So let's see the solution of this problem. In this one, what you need to find the resistance between 1 and 2 and the grid is infinite. So these kind of problems we have already seen. If there is infinite grid, then how do we find the equivalent resistance? So this is 1 and 2. Between 1 and 2 you need to find. So what you will do? You will connect a current source of I here, right? Current source of I you will connect. Right? So if I connect the current source of I connect the current source of I. So if I connect the current source of I, so I current is getting in here. I current is getting in. I current is getting in. So that will be divided into 3 parts. I by 3, I by 3 and I by 3. So this current would be I by 3. I will connect a current source of I and calculate voltage V here. This is my target. So my R equivalent, that would be V by I. So basically I need to calculate V in terms of I. That's it. This is my target. So from here, if I say I current is going in, so I current has 3 paths, I by 3, I by 3 and I by 3. And from here, if I say I current is getting out, I current is getting out. That means this current would be coming from 3 paths as well. I by 3, I by 3 and I by 3. So this current, there is another I by 3 current. So basically total there is 2 I by 3 current. So this is the way we solve it. I have given the proof as well. Why do we do it? In the lecture only you will see why we do these kind of analysis. So if I is getting in, I has 3 paths and I is getting out, because whatever the current that goes in, that will comes out. So if I current is getting out, from here, that means it would be coming from 3 paths as well. So there is 2 I by 3 and this resistance is R. One of the resistance is R. This resistance is R. So what will be the value of V? V will be R into 2 I by 3, right? R into 2 I by 3. because voltage V is the voltage across 1 and 2. Voltage V is the voltage across 1 and 2. So V would be R into 2I by 3. So V by I, that is R equivalent, that would be 2R by 3. That's it. This is the answer. Okay. Very easy. So let's see the solution of this particular problem. This is a very interesting problem, and this was asked in Olympiad. Okay, it was asked in physics Olympiad in 2013. So from there I got this problem. So what they are saying, initially your 2C is having 8 coulomb charge. 2C is having 8 coulomb charge. This is 2 farad only because C is 1 farad. So charge is 8 coulomb. Charge is 8 coulomb. What is the capacitance? That is 2. So what will be the voltage? Voltage will be 4 volt. So initially it is having 4 volt. This is what you know, right? So initially this 2C capacitor is having 4 volt, and this would be having 0 volt because nothing is given, and inductor current would have been also 0, right? Find the time t at which the inductor current is maximum. The switch S is open. Switch S is open. Switch S is open. So you need to find the time t at which the inductor current is maximum. What will be your inductor current? Initially your inductor current is 0, and at steady state also it will be 0 because there is no source involved. So inductor current will be sinusoid. My inductor current, I don't know the magnitude. It would be some magnitude A, but the current will be sinusoid. That I know because initially it is 0, at steady state also it is 0. Current will be sinusoid. I hope you know the expression. How do we write the expression directly? So it would be sinusoid. So, and what will be the omega naught? Omega naught will be 1 upon root L equivalent C equivalent. This would be your omega naught. What will be your L equivalent? These two L are in series, so it would be 3L. And what will be your C equivalent? These two C are also in series. So what will be your L equivalent into C equivalent? That would be 2LC. So what will be your ILT? Why I am not caring about the magnitude here? Why I am not caring about the magnitude? Because I need to find the time t at which the inductor current is maximum. I just need to find the time t at which the inductor current is maximum. So I do not need to care about the magnitude. They are not asking me the maximum current. They are asking me about the time. So 1 by 2 root LC. LC value is L into C is 2 only. So 1 by 2. So omega is 1 by root 2 LC, and L into C is 2 only. So it would be 1 by 2. So when this expression will be maximum? When this expression will be maximum? Maximum. At what time this will be maximum? When t by 2 is equals to pi by 2. Say yes or no? Sinusoid. Sinusoid expression. At this time it will be maximum, no? So t by is equals to pi by 2. So that means t is equals to pi. So that's it. This is the answer. So at pi second it is maximum. So in the examination, if they are asking only the time at which it is maximum, then you don't need to care about the magnitude. Say yes or no, right? Now let's see in the next question what they are asking. The time t at which the inductor current is maximum, at that time what is the value of Vc2? The time t at pi second. So they are asking what is the value of Vc2 at pi second. This is what they are asking. So I need the value of Vc2. Now I need the value of Vc2. The switch is still open. I need the value of Vc2 now. So how do I calculate Vc2? I need to calculate Vc2. How do I calculate it? Now if I directly go by that method, that initially it is 0, it would be tough for me because there are two capacitors, 2C and C, L and 2L. There are two inductors, although I can make it 1, 2L by 3 I can make. But there are two capacitors. So these kind of condition we haven't seen. We have seen simple condition. There was one capacitor and one inductor. But here there are two capacitors. This is also having some initial charge. Actually, what would have been happening that this 4 volt would be charging this inductor. 4 volt would be charging this inductor. So current would be flowing in this manner. So this C will charge in this direction. This would be happening. But it will be very tough to write down the equation intuitively. But what I can do, I can find out the current. If I am able to find out this current is equals to inductor current only. If I am able to find out this current, then I will be easily writing down the VCT equation. Because what will be VCT equation? 1 by C integration I dot dt. So I just need to integrate after that. So first I will find ILT. Now in ILT I know this will be there, but I need to find the magnitude. So how do I find the magnitude? Now my target has become to find ILT. So this was the scene. Initially at t equals to 0, this was the scene. Now L and 2L would have become 12 by 3, right? L and 12 would have become, L and 12 both are in series. So it would have become 3L. 3L. This is having how much? 4 volt. Right? This is having 4 volt. And this is having 0 volt. what you need to find? You need to find this current, right? ILT. So this is 0 volt, this is 4 volt. So you are having 4 volt across the inductor. Initially you are having 4 volt across the inductor. So what will be your ILT? 4 volt across the inductor. So what will be your ILT? Voltage into equivalent capacitance. What will be the equivalent capacitance? 2C and C are in series. So it would be 2C by 3 into equivalent inductance. And then sinusoid T by 2. Sinusoid T by 2. That would be 4 by 3 into root 2C by L. 2C by L. So 4 by 3 sin T by 2. So that would be the ILT current. So this is my ILT current. Now what do I need to find? I need to find VC2T. So what will be your VC2T? VC2T. VC2T would be 1 by C2 integration ILT dt. But see the direction. See the direction. Direction is the opposite. So here I will put the negative sign. So minus 1 by C2. C2 is 1. C2 is 1. C2 is C only, that is 1. And then integration you need to do. The current is starting. The current will start from t equals to 0. Everything will start from t equals to 0. Okay. Although nowhere it is mentioned it is starting from t equals to 0. But initially it is open. Initial charge is there. That is 4 volt. So it is starting from t equals to 0 only. So from 0 to till time t. I need to integrate this expression. That is 4 by 3 sin t by 2. Right. From 0 to t. Now minus 4 by 3 will come outward. What is the integration of sin theta? Integration of sin theta is minus cos theta, right? So minus cos theta is the integration. So minus sign will be cancelled. And sin t by 2. Here I will do the 1 by 2. So 2 would come here. It would become 8 by 3. Sorry, this would be cos. This would be cos. Simple integration I am doing. You have to do the integration with patience. 4 by 3 was there, minus sign would come, minus would get cancelled, cos t by 2 is there, and we will do the differentiation of t by 2 downward, so 2 would come upward, so 8 by 3 and from 0 to t. So what we are getting, the expression of Vc to t is 8 by 3 cos t by 2 minus cos 0 is 1. So at what time we need to find? At what time we need to find? We need to find at pi second. Vc to t at pi second. What that would be? 8 by 3 at pi second cos pi by 2 minus 1. So cos pi by 2 is 0, right? Cos pi by 2 is 0. So answer is coming out to be minus 8 by 3 volt. Well and good. Yeah, so this was coming minus 8 by 3 volt. Okay. Now what we are doing, the answer is minus 8 by 3. Now in the next problem, what we are doing, now at time t, the time t at which the inductor current is maximum. So at pi second we are closing the switch. At that time we are closing the switch. So and it remains closed afterward. So what is the maximum value of ISW? So this was the scene basically. Now this switch closes at time t equals to pi. This switch closes at time t equals to pi. At that time, what was the voltage across this capacitor? That was 4 by 3 in this direction. Say yes or no? 8 by 3 or 4 by 3? 8 by 3, 8 by 3. 8 by 3 in this direction. 8 by 3 volt. At that time, what was the current in the inductor? At that time, what was the current in the inductor? That was maximum, and that was maximum current would have been IL max, ILT max. That would have been 4 by 3 ampere. Say yes or no? Because at t equals to pi, the current would have been 4 by 3 ampere. At t equals to pi. T equals to pi, you would have put sin pi by 2. Sin pi by 2 is 1. So magnitude. So this is the current expression. That would have been 4 by 3 ampere. So current would have been 4 by 3 ampere. So this current would have been 4 by 3 ampere. Also this current would have been 4 by 3 ampere. This is L. This is 2L. L 2L, right? Upper one is L. Upper one is L. Lower one is 2L. L and 2L. This is 4 by 3. This is 4 by 3. This is having 8 by 3. You don't know the voltage across this 2C capacitor. Now we did this much of analysis to find the voltage across the capacitor. Was it really required? Let's check that out. This was the complete expression of VCT, but I need to find only when the inductor current is maximum, right? The inductor current is maximum. This is the waveform of inductor current. Inductor current is maximum at this point. So at this point I need to find the voltage across the capacitors, right? At this point I need to find the voltage across the capacitor. So this is the point when inductor current is maximum. If at this point inductor current is maximum, then what will be the inductor voltage? At this point, what is the slope? Di by dt. At this point, di by dt at pi. What is that? 0, right? So in the next page I will write it. dit by dt, dilt by dt at t equals to pi. That is 0. That means what would have been the VL? That would have been the 0 volt, because VL is L di by dt. That would have been 0 volt. Now this would have been your 2C, this would have been your C. C is having 8 by 3 volt in this direction, 8 by 3 volt in this direction, and at t equals to pi I am drawing. At t equals to pi there is slope 0. That means when inductor is having maximum current, it would be shorted. So inductor will be shorted. Inductor is shorted, right? This is your 2C. So if this was having 8 by 3 in this direction, then this would have been having 8 by 3 in this direction. Say yes or no. Say yes or no. If this was having 8 by 3 in this direction, this would have been having 8 by 3 in this direction, because from here, if this is 0, 0 minus 8 by 3 plus 8 by 3 again 0. So KVL is valid. Simple KVL is there. If this is 0, this is minus 8 by 3 and this is also 0. So this would have been having 8 by 3 in this direction. So now at this point, this capacitor is having 8 by 3 volt. Also, how you could have find this value? Let's just say this is your 2C, this is your C, and the complete circuit is shorted. I know one thing, that my 2C was charged for 4 volt. I don't know how the charge distribution has made, but I know one thing, the current would have flowed in this direction and this capacitor would have charged in this direction. So charge conservation will be there. Say yes or no. Charge would have been conserved. So 2C into 4, this was your initial charge. When the current is maximum, at that time also the charge has to be same. Say yes or no. And if 2C is having V volt, C would have minus V volt. If 2C is having, let's just say if 2C is having V volt, at t equals to pi, if 2C is having V volt, then C would have minus V volt. Because if this is V, so this has to be minus V. Then only both will be equal to 0. This was the initial charge. What was the initial charge? Initial charge was 2C into V. Say yes or no. Initial charge was 2C into V. At t equals to pi, the inductor current is maximum, so this is shorted. So charge would be the same only. Charge is going nowhere. We don't know the voltage. Let's just say this voltage is V, this voltage is V. If this voltage is V, this would have been minus V, because inductors are shorted. So total voltage would be 0. So this 2C is having V voltage. That means 2C is having 2C V charge. Then C would be having minus V voltage. Say yes or no. So 8C is equals to CV. So V is equals to, wait a second. Something is wrong here. Charge conservation is not valid here. 2C into it was having 4 volt. Then 3C X voltage. So 8 by 3. V in this direction. This is the condition. This was 2C. This was having 4 volt. So this would charge the capacitor in this direction. Both will have the same potential. So actually here plus should come. So plus should come. If you don't get this method, because this is very, like, where you have to go in very depth, then at least you can find this one, minus 8 by 3. Then you can easily tell it would be plus 8 by 3, right? And why we are caring about it? Because the switch has been closed now. So we need to find this current expression. If you need to find this current expression, then you need to find this current expression. Then let's just call this as IL, and then this current expression I12. Then what will be your I switch? I switch would be IL minus I12. IL minus I12. So IL minus I12, this is my target. So that's why I am finding this. So from here I get to know that this would be 8 by 3 and this would be charged in this direction. From the positive, this would have been also 8 by 3. Or if you remember the switch capacitor, this is your 2C. This is your 2C which is charged to 8 by 3 volt. And this node of C is connected to this capacitor in this direction. Lower node, this lower node is this plate, and this node is this plate. So this is 4 volt, this was 4 volt. Initially this was 4 volt. So if you need to divide the voltage, how it will be divided? You can see both will have 4 volt, both will have V volt in this direction, both will have V volt in this direction. So 2C into 4 is equals to CV plus 2CV. So 8C is equals to 3CV. So V would be equals to 8 by 3. So 8 by 3 volt you will get. So on both of the plate you will get 8 by 3, but one will have the opposite direction. Okay. So on both of the plate we will get 8 by 3. So from here I get to know that my V is 8 by 3 volt. So this will have 8 by 3 volt, this will have minus 8 by 3 volt. Are you able to get this concept? 2C was having 4 volt. So 2C into 4, then 3C into 4, 3C into V. So V would be 8 by 3 volt, right? So now this is my 8 by 3 volt, this is also minus 8 by 3 volt. Now I need to find the expression of ILT. So IL is initially having some current, that is 4 by 3 ampere. So because of that some current expression would come. There are two sources. One is this voltage because of the capacitor. Because now switch has been closed. Now this is the scene. The switch has been closed now. So now this 8 by 3 voltage is directly exposed towards the inductor. And now this 8 by 3 voltage is directly exposed towards this 12 inductor. Okay. And this is your I switch, which I can make here. So this 8 by 3 current is directly exposed towards the inductor. Yes or no? This is an inductor. And if I say I am giving V voltage to it, then where it will drive the current? In this direction. So this is your inductor. And you are giving 8 by 3 voltage to it in this direction. 8 by 3 voltage. So where it will drive the current? In this direction. So because of 8 by 3 the current will be opposite. But let's just write down the current of ILT. Let's just write down the current ILT. So initial current is 4 by 3 ampere. At steady state this current will be 0. So how the response will come? Cosinusoid. Initially is 4 by 3. So cosinusoid will come. 4 by 3 cos omega naught t. Because of 8 by 3. Initial current is 0. Because of 8 by 3 initial current is 0. At steady state also it will be 0. Because of this 8 by 3 volt. This is 8 by 3 volt which is exposed here. So what is the initial current? I am applying superposition theorem. What is the initial current? 0 only. This is a voltage. The current is 0. At steady state what will be the current? Again it will be 0. At steady state also it will be 0 only. Because inductor will act as short circuit. There will be no current. So that means what will come? 1 minus cos omega naught t. Right? So plus 8 by 3. This is the voltage. Then you need to multiply with what? This is voltage. So V by R. I is V by R. So you need to multiply with root C by L. So what will be your root C by L? C is 2C. Root 2C by L. 1 minus cos omega naught t. So this is your final ILT. What about I12T? I12T. Initially it is driving 4 by 3 ampere current. So 4 by 3 cos omega naught t will come. And because of this 8 by 3, in the opposite direction current will flow. So minus 8 by 3 into 2C by L. 1 minus cos omega naught t. Say yes or no? Minus 8 by 3 into, sorry. Here this resistance will change. What will be the impedance? Impedance will be C by root 2L. C by root 2L. 1 minus cos omega naught t. Well and good. This is your I12T. Right? So what is the value of C and 2C? What was the value of C and C is 1 and L is 2. C is 1 and L is 2. 4 by 3 cos omega naught t minus C is 1 and L is 2. C is 1 and L is 2. This would be 1 by 2. 1 minus cos omega naught t. and this is your ILT. So C is 1, L is 2, so this would be 1 only. Actually this would be 1 only. So let's write down your I switch equation. I switch would be what? That would be 4 by 3 cos omega naught t, IL minus I2L, 4 by 3 cos omega naught t, 4 by 3 cos omega naught t plus 8 by 3, and C is 1, this will be cancelled, 8 by 3 into 1 minus cos omega naught t minus 4 by 3 cos omega naught t plus 4 by 3 plus 4 by 3, right, plus 4 by 3 into 1 minus cos omega naught t, 4 by 3 into 1 minus cos omega naught t. So what we will get here? 12 by 3, that would be 4 into 1 minus cos omega naught t. This is your I switch. So if I put what will be the maximum value of this one? That would be 2, right? 1 is 1, this can be minus 1, so it would be 2. So what is your ISW maximum? That would be 8 ampere. So that's it, this is the answer. Okay, right? So there is a slight error that I made here. That is, here it will not be 1 minus cos omega naught t, right? It would be cos omega naught t only. 1 minus will not come, because at t equals to 0 you are having 0 current, at infinity as well you will have 0 current only, because there is no source involved. This is the initial condition of capacitor voltage, so there is no source involved, so it will not be 1 minus. This 1 minus is wrong. It will not be 1 minus. 1 minus will not come. This 1 minus will not come. This will not come. So what will be the maximum value? That would be 4 ampere. Okay, so that was an error. Maximum value will be 4 ampere. So a slight error I made in writing down the equation. So this should not have happened. Well and good. Okay then. Yeah, so that's it. So this was a good question. Now the complete question may not come like that. These kind of things may not come, but they can ask you these values, like what will be your VC value at that time, what will be your VC2 value. So you should have an idea how do you write down these values. 8 by 3, how did I get minus 8 by 3? And I got it very quickly, right? In this one I told you the time t, very quickly I could get to know that it is sinusoid, so I could get to know that it is pi. And even if I needed the expression, then also I could write down the expression very quickly, because 4 volt will directly come here and then I can directly write down. And if I needed the value of VC1 and VC2 as well, then if I go by this method, this will also not take much of time. But if I have so much of aptitude that at maximum current the inductor will be shorted, then I could get to know that in my charge conservation I can apply. So in charge conservation I will get to know that it will charge in this direction. So how will I apply charge conservation? So this is how I will consider it. Both of them in parallel I will consider it in this manner. Then I have already studied. This is 2C, this is 2C was having 4 volt. So 2C into 4 volt, C1V upon C1 plus C2. This I have already studied. So this would be 8 by 3 volt. So this would be 8 by 3 and this would be minus 8 by 3. So directly I would have write down these potentials as well. And if I know these potentials, then I can make this circuit and directly I can write down the equations as well. And if I know the equation, I would know the equation of ISW as well. So ISW equation will be 4 cos omega naught t. So answer maximum current would be 4 ampere. Well and good. Okay then. Yeah. So that's it.